Sound check. Hello, hello. Good morning. Good morning, everyone. Good morning, my dear students. Okay, ilan ba yung viewers ko ngayon? 57. Kumusta kayong lahat dyan? 57 viewers. Okay, I hope mga pure online class lang kayo, no? I hope walang mga nag-face-to-face, no? Walang nag-choose na hindi papasok. Okay? Ano lang natin, no? Remind lang natin, no? Less than 100 days na lang before your board exam. No, less than 100 days. Na sa 97 or 96 days na lang before the board exam. Okay? So, I hope malaki na yung progress ninyo, no? I hope malaki na yung progress. Okay. Oh, NBA Finals pala ngayon, no? Ano ba natin yung ano? Yung score? Dapat updated. Ilan yung score? Later. Pakita natin. Anyway, our topic for today is this, no? Combined stress calculation involving pre-stressed concrete and foundation pressure. Okay? Combined stress calculation. Now, last week, di ba, we tackled combined axial and bending stresses, right? We saw how easy it is to compute stress on a section when both axial and bending loads act together, now especially in cases like eccentric loading, like if the load is not applied along the longitudinal axis. No, ang ginawa natin is simple lang, no, we simply superimpose the stresses. For axial loads, we use P over A, no, the normal stress formula, no, P over A, positive for tension, negative naman for compression. Then we add the bending stress. Remember, MC over I. No, positive natin sa tensile zone, and negative naman sa compressive zone. Kung saan papunta yung ikot, no? Doon papunta yung compressive zone. Okay? Kung ano yung head ng arrow natin, no? Yan yung compressive zone, while the tail naman, tensile zone. Okay? Now, here's the thing. Now, concrete, while very strong in compression, is naturally weak in tension. Diba? Alam natin yan, no? So, kapag na-expose siya sa bending, the tensile zone becomes critical part. No, madali siyang mag-crack or fail. No? So, the question is, how can we help the concrete resist that tension even before service loads are applied? No? So, that's where pre-stressed concrete comes in. Okay? Yan yung lecture natin for today. Okay? Good morning, sir. Ask ko lang po if may na-upload na po ba kayong PDF file? Wala pa, no? I always forget ba? Nawala kasi yung flash drive where I stored my PowerPoint. Sige lang. During the break, I'll try na ma-upload ko, no? Sa website. Okay? So, sorry talaga. Anyway, proceed lang muna tayo. Okay? So again, ito yung pag-usapan natin. Pre-stressed concrete. Okay? Pre-stressed concrete. Okay? So, pre-stressed concrete is a technique where we introduce internal compressive stress into the concrete member before it is subjected to any external load. No, para bang binibigyan natin ng panangga, no? Si concrete against tension. Now we do this by tensioning high strength steel cables or wires. And kapag tumigas na ang concrete, and we release the tension from the steel, the concrete gets compressed. Okay? This compression offsets the tensile stress that would normally occur under load. Okay? So, ganun yan. No? Pre-stressing involves introducing internal stresses into a concrete element before it's subjected to external loads. So that's done by tensioning steel reinforcement cables, wires, or bars within the concrete before it hardens. Then when the concrete has cured and the tension on the reinforcement is released, the concrete compresses. Then this compression counters the tensile stresses that will occur when the element is put into service. Okay? So, ganun yan, no? Now, merong dalawang types of pre-stressed concrete. No? The pre-tension concrete at saka the post-tension concrete. No? Sa pre-tension concrete, in this method, the steel is tension, no? Before you pour the concrete. So, nakahila na ang steel habang fresh pa ang concrete. And once the concrete cures, we cut or release the tension, and the force transfer to the hardened concrete, putting it in compression. Now, say sa post-tension concrete naman, dito we pour the concrete first with the ducts and holes left inside. Okay, then after the concrete has hardened, saka natin ite-tension ng steel by pulling it through the ducts using hydraulic jacks. Okay? And then anchoring at the ends. No? Mag-anchor tayo sa ends, and that compresses the concrete afterwards. Now, to help you visualize this, tingnan niyo ito, no? Imagine a stack of playing cards or index cards, no? Kung wala kang rubber band, they can scatter easily, di ba? But if you tightly wrap a rubber band around them, na parang pre-stressing steel, now the cards are held together firmly. And that's exactly what compression does to concrete. Now it holds everything in place and helps the entire member resist larger loads without cracking or breaking apart. Okay, so in essence, the pre-stressed concrete is like giving concrete an advance boost para hindi siya agad bibigay sa tension. Okay? Ganun yan. No? Ito yun. Ito, no? So, yan yung parang pwede natin magamit, no, to visualize the effect sa concrete. Pre-stressing tendon sa concrete. Okay? We actually have a video niyan, no, sa jersey book natin online, no? So if you have time, hanapin niyo ito, no? How pre-stressing works. Okay, sa jersey book natin sa jerseyrev.com LMS natin. Okay? So hanapin mo 'yan, no? And listen, no, ano yung explanation diyan. Okay ba? Okay. So, ito yung mga examples, guys, no, ng mga pre-stressed concretes, no? We'll have an example later nito, no? Mga structures that look like this. Okay? Mamaya. No, mamaya. Okay. Now, tingnan nyo ito, guys. Let's say ito yung ordinary reinforced concrete, no? Sa pag-build niyan, no, kailangan natin ng scaffolds, no? So if wala pa siyang tendons, wala pa siyang pre-stressing tendons, Okay? It will easily deflect like that. Okay? Pero if pre-stressed naman siya, okay, if pre-stressed yung concrete, okay, tingnan nyo. So, let's say, nilagay yung pre-stressing tendons dito, no? Let's say, sa gitna, no? Nasa, um, ano niya, nasa neutral axis niya, no? So, yung effect niya, pure, ano lang, compression lang. Na parang, pinush mo lang pag ganito yung mga, yung structure, no? So, walang masyadong effect. So, if it's, ano, suspended, no? It may deflect, di ba? But if the tendons are placed dito below the neutral axis, anticipating that the deflection is downward, no? So, ganito ho. Ganito yung mangyari if we are to lift that up, no? And merong weight, additional weight, or additional load. So, as it tries to deflect, no? Ito yung effect niya. Okay? So, parang malulusan na siya, no? From being initially compressed because of the pre-stressing tendons, no? After it's loaded, no? So, at service, maging ganito na siya, no? So, merong initial na compression. Okay? Merong initial na compression due to the post-tension tendons or bars or wires. Okay? Now, let's talk about what actually happens during pre-stressing process, no? Especially for pre-tensioned concrete, no? So, sa pre-tensioning, the tendons, these are high-strength steel wires or strands. And they are attached to a desired tension, no? Or stretched to a desired tension. Okay, parang hinihila muna natin, no? So, ganito yung figure. Okay? Ito yung tendons. No, hihilain natin yan with a desired tension. No? Then, after that, we place the fresh concrete around the stretched tendon. No? Take note, this is tensile, no? Stretched. Then we pour the concrete. And while the concrete is curing, the tendons stay in tension and eventually become bonded to the concrete throughout their length. No? And once the concrete has hardened and reached sufficient strength, we release the tendons by cutting them at the anchorages. No? Siyempre, since the steel was stretched, na gusto nitong bumalik sa original length niya. No? So it tries to shorten. But since it's already bonded to the hardened concrete, hindi na siya basta-basta makakakilos. No? So instead, it pulls on the concrete and transfers the force into it. This is what we call pre-stressing. Okay, the result is that the concrete gets compressed, no? So, here's the interesting thing dito. Now, because of this internal compression, the beam actually bends lightly upward. Now, we call it the camber. Now, we call this camber effect, no? So, wait. Ito. As we cut the wires or the anchorages, no? Magiging ganito siya. Okay? So this is called camber. Now it's like pre-deflection in the opposite direction of the expected load. Okay? Parang naka-zoom yung PPT. Hello, oo, no? I noticed. Wait muna, guys. Ay. Kaya pala. Thank you, guys. How about that? Yun na. Okay? So, again, as we cut the, the wires, okay, at the, wait. Pero asan yung ano ko? At the anchorages, no? So, meron siyang slight bending, no? Upward. So that is called camber. It's like a pre-deflection in the opposite direction of the expected load, no? So it's a good thing para parang built-in resistance siya na sa pagkakasag ng beam once na may load na. No, so in summary, i-stretch yung tendons, okay, hilain, pour the concrete, no, and let it harden and bond with the tensioned tendons. Then after that, release the tendons, and this mag-try yan mag-compress or back to its original length, no? And yung effect niyan, it will compress the concrete, no? So matransfer yung compression, and the beam cambers up, no? And that's how pre-tensioning works, step by step. Okay? So ganun yan. No? Now, if loaded naman, so it goes back to that. Ganun siya, mga kapuso. No? Now, post-tensioning naman. Sa post-tensioning, in this method, the tendons are not placed in direct contact with the concrete. No? Instead, they are encapsulated inside a protective sleeve or duct na parang may lagusan or tubo na dinadaanan ng tendon. I was supposed to, I was supposed to make sign, but parang bastos tingnan, okay? Parang may lagusan or tubo na dinadaanan ng tendon sa loob ng concrete. Now, this duct is either cast into the structure or placed alongside it during construction. At each end, at each end of the tendon, na merong anchorage assembly, no? Firmly fixed to the concrete, no? So dito natin i-apply ang tension later on, no? Now here's what makes post-tensioning different. Now we don't stretch the steel before pouring, no? Not like the pre-tensioning, no? We pour the concrete first, okay, let it cure and gain strength. Okay? Then we apply tension. Now after the concrete has set, now we use hydraulic jacks to pull the tendon ends, not through the anchorages. Okay? So let it cure. Okay, then i-pull, then it will make like that. No, it will act like that. Okay? So, habang hinihila natin yung tendon, it pushes against the anchorage, which in turn pushes against the concrete. So, kahit hindi bonded agad sa concrete, like pre-tensioning, the tendon still compresses the member through that anchorage reaction. Okay? No, dito ilagay yung mga anchorage sa dulo. Okay? This process puts the concrete in compression after it has hardened. Hence, the name post-tensioning. So again, same goal as pre-tensioning, apply compressive stress to help concrete resist future tension. No, but the technique and timing are different, no, for post-tensioning. Okay? Now, stress calculation tayo. Okay, so say this is the beam, no? Let's say a long beam, a very long beam, no? Carrying vertical loads, no? So magdi-deflect yan, no? And malaki yung magiging tensile stress dito sa bottom, no? And that's why sa RC design, di ba? Reinforced concrete design, for beams, no? We are to design reinforced concrete beam, where dapat the reinforcement nasa nasa bottom, no? At the midspan section. 'Di ba? Kasi yung tensile zone nasa midspan is nasa bottom. Okay? Ay, sis, my baby is so cute looking at me. Ay, he's looking at me. So, let's say ito yung stress due to the prestressing force P, you know? The stress on the concrete is equal to this, no? It's negative P over A plus and minus M sub P times Y over the moment of inertia, no, with respect to the neutral axis. Okay? So, yan yung magiging stress dyan, no? So, negative kasi compression yung effect, no, ng pre-tensioning, no? So, negative P over A. Okay? Then, plus and minus, depende kung saan yung zone na i-consider mo. Sa tensile zone, which is dito, no? Tensile zone dito, positive. Compressive zone naman dito, negative. Okay? So, ganun yan. Now, take note, the moment na ito, M sub P is equal to P times E. Now, the pre-stressing force times the eccentricity. Okay? The distance yan from the centroid to where the force is applied. So, we can write this formula. We can rewrite this formula as this. Now, negative P over A plus and minus PEY over I. Okay? So, again, that negative P over A, that's the direct compressive stress from the prestressing force. And that plus and minus PEY over I is the bending stress caused by the eccentricity of the tendon. No? Ganun siya. Again, same principle from last week. The superposition, no? We add the axial bending and bending stress effect, no? I-add lang. Okay? I-superimpose lang sila. Now, next naman is the stress due to the external loads. So, if this is having a moment, say positive moment, no? So, the stress due to that load M or M sub L is equal to this, no, plus and minus M sub Ly over I, no, moment due to the load times Y over the moment of inertia with respect to the neutral axis. Okay? So again, positive sa tensile tension aside, no? In this case, if the moment is positive, no? If the bending moment is positive due to the vertical loads, then nasa itaas yung compression, nasa baba yung tension. No? Ganun po. At the midspan of the beam. No? So, the total stress at any fiber, guys, is this. No? F is equal to negative P over A plus and minus PEY over I plus and minus M sub Ly over I and A. Okay? Ganun lang. No? Yan yung total stress at any fiber. No? Now, kung gusto nating makuha yung maximum stress, now we simply use C. Now, that's the distance from the neutral axis to the extreme fiber instead of Y. So, the formula becomes ganito. Negative P over A plus and minus PEC, no, over the moment of inertia plus and minus M sub L, moment due to the load, times C over the moment of inertia. So, ganun lang ho. Ganun ho, mga kapuso. Okay? So, the total stress, no, we're still combining the axial and bending effects. No, pero kasama na dito si prestressing force, no? So, just remember lang, no? To use the correct signs depending on tension or compression. Okay? And don't forget the eccentricity E. No? And most importantly, na i-superimpose mo lang everything properly. Okay? Superimpose mo lang properly. So, we'll try solving a sample problem, no? Para mas klaro. Okay? So, eto. Ito pala yung stress distribution. No, sorry. Wala pa pala. Stress distribution pala. May practice, I forgot, no? Yes, merong practice problem ito. Okay, meron ho. Uy, may score no? No, may score ng ano. Oh. May score na. Hindi man nakikita sa ano. 18-18. Okay. Wait muna guys ha. Hanapin ko muna yon. Yung practice problems. Ano ba yun? Wait guys. Okay. Axial unbending. Pero baka need ko pang dagdagan to guys, no? Need ko pang dagdagan yan. Parang wala pa masyado sa pre-stress. Okay? I don't know if nabigay ko na ba yan? Nabigay na ba yan? No? Nag-upload ako dito sa Padlet. Tignan niyo. Tignan niyo. Okay? Dagdagan ko yan guys, no? Okay. So, ito yung stress distribution. Okay? So, ito yung stress due to the axial load, no? So, this comes from negative P over A, no? So, pantay yung compression from top to bottom. Okay, then we add bending stress due to the eccentricity. Okay? So, from maximum compression dito sa bottom, no? And tension naman on the top. Okay? Because of that post-tensioning or pre-tensioning. Okay? Now, so, dito naman, yung stress naman dito, again, is PEC over I, na positive, dito naman negative. Okay, now, due to the bending moment naman, due to the loads, no, ito naman yung stress distribution, no? Compressed dito sa itaas, tensile dito sa baba. Okay, so, positive MC over I, negative MC over I sa itaas. So, if we are to combine them, now the resultant stress distribution is this. No? Uh, pwede that the top is maximum compression, no, while the bottom naman is minimum compression, or meron din, pwede rin na it's still tensile. Okay? So, yan yung stress distribution niya. Sir, I have a question. Yung negative P over A, always po ba gamitin negative sign? Yes, kasi post-tensioning, compression yung effect niya on the concrete, no, as we release the anchorage, no? Yan ho. Okay. Example tayo. Example tayo, guys, no? So, pre-stressed concrete beam. Okay? So, dito we are given a simply supported rectangular beam with dimensions 300 by 600 millimeters. Now, spanning 12 meters. Okay? Simply supported. No? And the beam carries three types of load dito. No? A superimposed dead load of 5 kilonewton per meter. Live load of 15 kilonewton per meter. Now, and of course, it has its own weight. Now, its own self-weight. Now, which we'll get using the unit weight of concrete equal to 23. Okay, 23 lang yung unit weight dito. Okay? Now, here's the important part. Now, the beam is pre-tensioned with a total initial pre-stressing force of 1,750 kilonewton using low relaxation strands. Okay? And the tendons are placed 220 millimeters below the neutral axis. Okay? So, there's eccentricity involved. No? Now, at service load, at service condition, there is a 15% loss of pre-stress. Okay, which means we need to account for that when calculating stress after the beam is in service. No? After i-add natin yung mga as we add the live load, superimposed live dead load and live load. Okay? So, ganun siya. No? Now, these are the three things being asked dito. First, no, the stress at the bottom fiber at the end span due to initial pre-stressing force only. So, dito, we're looking at the effect of the pre-stress alone na before service loads are even applied. Okay? Now, next naman, we're to find the stress at the top fiber at the mid-span. Okay? Due to the service loads and the pre-stressing force. Okay? So, this time, include na natin yung loss, no? I-take into account na natin yung loss of the pre-stress dito. Then, third, yung tanong dito, yung how much additional uniform load can we apply to the beam without causing any tension in the concrete at the mid-span. Okay? So this one's a capacity check, no? Up to what point pwede nating dagdagan ang load before the concrete starts to crack from tension. Okay, so overall, this problem covers yung mga discussion natin, no? Yung na-discuss natin, pre-stress, stress from loads, and their combination. So, isolve natin to. Solve natin. Ito yung diagram, no? Ito yung figure na ma-draw natin from the statement. No, the beam is 12 meters long. No, a long beam, no? And it's carrying superimposed dead load na 5 kilonewton per meter and live load of 15 kilonewton per meter. And ito yung cross-section of the beam, rectangular, 300 by 600 millimeters, no? And the tendons are placed dito with an eccentricity of 220 millimeters below the neutral axis. Okay? Yan. Ayan yung figure na ma-draw. No? Now, I want to say something dito, guys, no? Many of the students na fall sa trap na ito, no? Just because the problem gives you dead load and live load, okay? Kita niyo dito, merong dead load, meron ding live load, doesn't mean you should automatically use load combination na 1.2 dead load plus 1.6 live load. No? Huwag mong i-apply yan, okay? Hindi ito RC design, hindi ito reinforced concrete design problem. Now, we're not designing for the strength yet of the concrete. No? We're checking service stresses, no, in prestressed concrete. Now, that's very different. Now, in prestressed concrete analysis, lalo na sa stress checks like what we're doing now, we work with actual service loads. That means, yung dead load, as is lang yan. No? Live load, as is lang din yan. Okay? Walang factors, walang 1.2, walang 1.6, walang load combination. Naintindihan? No? Because we're not checking ultimate strength here. No? Yung sa pattern loading, dami na yabo sa 1.2D plus 1.6L. Pero nakalagay na nga na ultimate condition. Yun nga, no? No, dito wala. Okay? Wala ho, no? So, we're not checking ultimate strength here. Now, we are checking how much compressive or tensile stress is acting on the beam under normal operating conditions, where cracks or excessive tension should be avoided. So, ulitin ko, if the question is asking for stress like tension or compression in the fibers, do not use factored loads, no? Use service loads directly. Okay, reserve your load combinations for ultimate strength design. Okay, that's a different topic, no? Different discussion. Okay? So, nakadiscuss na kayo niyan with Sir Tariga, no? Daming nayabo. Should we maintain po being in the 90th or 80th percentile hanggang refresher exams para maka-avail for discount sa refresher, or at least hanggang review exams na? Hanggang review lang, no? At least hanggang review. Na i-maintain mo yung 80th percentile. Sir, paano po tayo mag-analyze sa cross-section nito? Pahiga ba or patayo? Patayo natin like this. Yan, patayo. No? So, ito yung part 1, guys. Na calculate the stress at the bottom fibers of the concrete at the end of the span due to initial pre-stressing force. The formula is again ito, no? Negative P over the area, and since this is just rectangular, now the area is B times H, then plus and minus MC over I. Now, remember, na since this is rectangular, pwede natin gamitan yung 6M over BD squared, no? 6M over BD squared for rectangular cross-section. No, for any other section, stick ka to MC over I, pero rectangular lang, mas madali. So, yung 6M over BD squared. Okay? But we're involving only the prestressing force dito. So, the prestressing force is 1,750. no? And the cross-section is 300 by 600. So, gawin nating Newton ito, no? Naka-Newton. Idagdagan natin ng tatlong zeros, no? 1,750,000 Newton over the area 300 by 600. Okay, so uniform stress. Then plus and minus 6m over bd squared. The m is p times e. Okay, yung p is 1,750. Yung e is 220. So 6 times 1,750,000 Newton times e 220,000 at 220 millimeters over bd squared. 300 times 600 squared. Okay? So, evaluate natin to isa-isa. No, this will result to negative 9.722 plus and minus 21.39. Okay, yan yung stress, guys, sa mga extreme fibers. No? Sa extreme fibers due to the prestressing force only. Okay? Now, there's a question again dito sa Padlet. Pwede po ulit pa-explain paano malalaman if plus or negative. Okay? So, inom muna ako ng tubig. Refreshing! Okay. So, paano mo nalaman if plus ba or minus? No? So, yung effect ng pre-stressing force is ganito. Di ba? Yung effect niya. It's combined axial, no? And bending. No? Ano papunta dito yung bending? No? I-compress niya yung bottom fibers, i-tensile niya yung compressive fibers. Okay? So, if i-calculate natin yung stress sa top, no? Tensile siya dito, di ba? Positive siya dito. No? Negative siya dito. Kung saan papunta yung arrow, guys, no? Saan papunta yung arrow na ito? Negative yan. So, negative P. Negative MC over I or negative, eto. Negative dito sa baba. Positive sa itaas. No? So, positive. Gamitin natin to. Positive. So, evaluate that. Negative 9.722 plus 21.39. Positive 11.67 megapascal. Okay? Yan yung nasa top fiber. Pero since sinabi dito, bottom fiber, no? Then, i-minus lang natin to. Okay? I-minus lang natin. So, negative 9.722 minus 21.39. Okay? And that is negative 31.11 megapascal. So, yan yung stress dyan sa bottom fiber. Okay, due to the pre-stressing force only. So, as you notice dito, walang i-apply na loss. No, walang i-subtract na loss. Okay? Wala ho. Now, yung pangalawang tanong naman, ano yung next question? Ito yung sagot. Pwede yung i-picturean yan, no? If gusto nyo. Nasanay pala kayo nito, no? Kaya pala minsan si bossing magdidemand, no? Sir, lagyan mo ng red box. Ilagay mo sa red box yung final answer. Nasanayan pala, no? Na nasa red box yung final answer. No? Kaya pala demanding si bossing noon. Naalala niyo si bossing? Andyan ka ba, bossing? Ayan. Okay. Next naman. Next naman. So, dito, part 2, i-calculate naman natin yung stress at the top fibers, no, in megapascal of the beam at the midspan due to the service loads at prestressing force. Okay? Yan naman yung i-determine natin. No? Take note, merong loss in pre-stress. No? Merong loss of pre-stress. 15%. Okay? So, sa midspan na tayo, guys. Well, i-calculate natin yung total weight. Total weight, no? So again, walang load combination na i-apply, no? Visibly superimpose them, no? So 15 kilonewton per meter. No, the live load, the dead load, and the weight, no? So dead load din yung weight, okay? So 15 plus 5 plus 23 times the area. Now, yung weight is gamma times the area. And that is in kilonewton per meter na. No? So that's it, guys. No? The uniformly distributed load caused by the weight is gamma times the area. Okay? That's it. Or gamma times the volume divided by the length. Diba? Which is just the area. Volume over the length. So that's why gamma times the area lang. Okay? Evaluating that, that gives us 24.14 kilonewton per meter. Okay? And the moment naman sa midspan, the maximum moment is WL squared over 8. Right? Yan yung formula. No? So, evaluate 24.14 times 12 squared over 8. That is equal to 434.52 kilonewton meter. Okay? And pwede na natin ma-solve yung additional na stress due to the applied loads, no? So, due to the load, again, gamitan lang natin ng 6m over BD squared or 6m over BH squared. No? So, 6 times the moment in Newton millimeters, so times 10 tayo, raised to 6. 434.52 times 10 raised to 6. Then over BH squared. Now over 300 times 600 squared. And evaluating that, that's positive and negative 24.14. Okay? Plus and minus 24.14 megapascal. Okay? Now, saan ba natin apply ito? Okay? Depende, no? Tingnan natin. Sa midspan. No? At the midspan, di ba, the bending is upward. No? Bending is upward, guys. If mag-draw tayo dyan, no? Compress sa itaas, tensile sa baba. Or, imagine mo the elastic curve niya. No? It bends that way. No? The fibers at the top are being compressed, the fibers at the bottom are tensile. No? So, if we're to solve for the stress at the top fibers, yung effect sa top, no? I-compress natin, no? Yung, i-negative natin yung stress due to the load. Okay? Due to the load. No? So, sa plus and minus 6m over BD squared, i-minus natin kasi compression at the top. Okay, so ganito yan, guys. Pwede natin gawa ng diagram. Kanina, we solved na the stress at the top due to the pre-stress with loss. If dagdagan natin ng loss, wala pa itong loss, no? Wala pa itong loss. Okay, so magbawas tayo ng 15% or times tayo ng 1 minus 0.15. Okay, so tingnan nyo ha. At the bottom muna tayo. At the bottom. So, at the bottom, yung 31.11. Now, magbawas tayo ng 15%. So, 1 minus 0.15. And that's negative 26.44 megapascal. Due to the, pre-stress yan, no? And that's the combination of the, axial and the bending caused by the eccentricity, no, of the prestressed tendons, no? So, ganito, negative. Now, sa itaas naman, 11.67 minus 15% niya. Minus 15% of 11.67 or 11.67 times 1 minus 0.15. Okay? That is 9.92. And the stress distribution niya is like this. No, pwede mong gawan ng stress distribution that way. Okay? Due to the pre-stress only with loss. Now, with loss of pre-stress. Now, due to the bending naman, take note guys, the top fiber is compressive. Now, the bottom is tensile. Okay? So, due to the load, now, negative yung sa itaas, negative 24.14. Now, sa top, sa bottom naman, positive 24.14. Okay? And of course, zero siya sa neutral axis, no? Kapag due to the load lang. No, but due to the pre-stress, hindi. No, hindi siya zero because of the eccentricity. Okay? Hindi zero ang bending stress sa neutral axis due to pre-stress. Hindi, kasi combination na siya of an axial stress and the bending stress. No? Ganun. So, if we combine natin sila, now we simply superimpose, no? I-add lang natin 9.92 minus 24.14, it's negative 14.22 sa itaas, sa top. Sa baba naman, sa bottom, negative 26.44 plus 24.14, that's negative 2.3. So both negative, both compressive, which is fine, no, kasi ano siya, ano tawag nito? Concrete, na concrete beam, so good in compression yung concrete. Yan yung effect ng pre-stress. Okay, so that's it. Negative 14.22 sa itaas, negative 2.3 sa baba. Ganun ho, mga kapuso. Okay, madali lang. So, negative 2.3, it means, sa top fibers, negative 4.22, compression, letter A yung sagot. No? Letter A yung sagot. Okay, naka-red box na yan ha, bossing. Baka mag-demand ka pa, no? Kaya may, iba ka pang demand dyan. Pag pinapahanap, sir, yung stress at specific Y due to both moment and pre-stress, mag-mode 3 to lang po. Pwede, no? Pwede ka mag-mode 3 to. Kung ano yung Y na merong, for example, merong 10 megapascal compression. Is that what you mean? Ano yung Y? Pwede ka mag-mode 3 to, no? Pwede kang mag-mode 3 to. Since linear lang yan. Na linear distribution lang. No? Score 36-37. Okay, 36-37. Thunder yung lamang. Okay, si yung lamang. Okay. Next naman. Sa part 3, sabi dito, calculate the maximum additional uniform load in kilonewton per meter that the beam can be subjected to without producing tensile stress in the concrete at midspan. Now remember, di ba, yung effect ng vertical loads, no, magiging tensile siya sa baba, no, kasi the bending is like that, no. if ito yung B yung section, I mean, if magka tayo dyan, na positive sa baba, negative sa itaas, no, compression sa itaas, tensile sa baba, yun yung effect niya. So, as we add more weight or vertical load, downward load, no, liliit ito. No, siguro lalaki ito, liliit ito. Yan, gaganon siya. Okay? So, dapat dito, where to find the maximum additional load that the beam can be subjected to without producing any tensile in the concrete at midspan. So, for this case, we simply, use this 2.3. No? Gamitin lang natin yung 2.3 na ito. No? So, 2.3 megapascal. No? Gamitin natin yung 6m over BD squared. Okay? So, dapat hindi ito lalagpas ng 2.3. No? So, solving for m, that's 2.3 times 300 times 600 squared over 6. That's 41.4 kilonewton meter. Okay? 41.4 kilonewton meter. And equate mo yan to the WL squared over 8. W is the additional. Okay? With length equal to 12. So, solving for that, no, cross multiply na lang. No, that is 41.4 kilonewton meter times 8 over 12 squared. No? And that is equal to 2.3. Yan yung pwede nating i-superimpose, no, or idagdag. Okay? Idagdag sa itaas, no? Without producing any tensile. Okay? Ganun ho. No? Pwede mo rin i-ratio and proportion, I think. No? Kanina, in our previous example, now we got a total weight of 24.14. This 24.14 causes a stress of also 24.14, di ba? It also causes a stress of 24.14. Nagkataon na parang makancel lang ito, no? Nagkataon sila, no? Na pareho yung kilonewton, but not all the time, ha? So, if were to solve for the W, that would give us a stress na 2.3 megapascal, no? So, for sure, 2.3 din ito. Yan. 2.3 din, di ba? Yan yung additional. Pero if ever man hindi, pwede, hindi pareho. No, let's say, nakalculate mo kanina due to the load was FL, no? So, to find the additional, i-ratio mo lang ito. Now, ito is F na pwede mong i-add. Okay? Then, i-ratio mo lang to the original na W to the F at the bottom. Due to the load. No? F due to the load. So, pwede mong i-ratio and proportion yan. Yan yung ginagawa ko noon, ng grade 6. No? Nagre-ratio and proportion na lang ako. Okay, kasi linear lang yan to the load, no? The increase of load, no, will also cause an increase in stress, no, linearly. Ganun po. Sir, kanos pwede magamit ang unit weight? Wait, nagamit man natin yung unit weight, di ba? Magamit siya if i-include natin yung dead load. No, kanina we added the unit weight, no? Dito yun, no? 23 times the area. Gamma times the area yan. No? So, unit weight po yan. Alright? Sir, bakit negative 2.3 ginamit natin instead yung negative 14.2? Again, no? Ito yung effect niya sa vertical loads, guys. No? Magtitensile siya sa baba. No? So, as we add additional load, additional distributed load, try to imagine, mag-increase yan, mag-increase. No, so, dapat yung increase niya hindi lalagpas ng 2.3 or else, maging tensile na talaga sa bottom, ang sinabi niya, so, without producing tensile stress. No, so, hindi yung sa itaas yung i-consider natin, but sa baba. Nakuha, kasi malayo pa yan 14.22 pa yan. And in fact, the more we increase vertical load, the more magiging compress sa itaas, no? The more yan magiging compressive sa itaas, no? As we increase vertical load, magaganito yan, guys. Magaganito, mas mag-increase pa ito. Nakuha ba? Ganun ho, no? So 2.3 yung i-consider natin, no? 2.3. Need po talaga until last exam ng review ma-maintain ang percentile rank at saka pa lang magbabayad sa last pay of review kung maka-avail ng discount for refresher? Hindi po ba malilate ang pag-join sa FB group or refresher? Kung gano'n, concern lang po para maiwas ang delays and backlogs for incoming refresher. I'm gonna tell this to our admin, no? Ano yung sagot nila nito, no? Okay, next. $40.42. Sayang dito ka watch ng live. Meron sana ako dito, no? Meron sana ako ditong NBA League Pass, no? I can watch live sana. I-play ko lang ito. Oh, malamang na yung Indiana, 43-42. Okay. Another example, guys. Another example. Ito naman. Ito naman ho, mga kapuso. So, this time, no, involves a prestressed hollow core slab now used in a real-world structure, a library floor. Okay, so let's understand the setup muna, no? The slab section is already prestressed. And we're given the following cross-section. 1.4 times 10 raised to 5 millimeters squared. Now, that's the cross-sectional area. And yung S sub T, S sub B, they are the section moduli. Okay, section modulus at the top and also at the bottom. Now, 6.8 times 10 raised to 6. It simply means na the neutral axis is nasa ano lang, nandito lang, no, sa gitna, no? Pareho yung S to the top kasi I over C yan, no, yung S. The slab is 1.2 millimeters wide and 200 millimeters thick. Okay? Then the prestressing force is equal to 820 kilonewton. Okay? And at an eccentricity of 63 below the neutral axis. So, doon usually nilalagay yung prestress, no, for a long simply supported beam. So the slab weighs 2.7 kilopascal, and there's a superimposed dead load of 2 kilopascal and a live load of 2.9, and it's simply supported on an 8-meter span, and there is a 15% loss of pre-stress at service. Now, here's what's we're asked for, no? First, we're to compute the stress at the top fiber at the ends due to initial pre-stress force. You can calculate that, no? You may even try that. Sige, I want you to try it muna before I show the solution. Kasi parang somewhat similar lang, no? Then the resulting stress at the top fiber of the slab at the midspan due to the loads and pre-stress force. And the third, the maximum total load, including its own weight, that the slab can be subjected to if allowable stress at service loads are not to be exceeded. At least, parts 1 and 2, masolve ninyo. Go! I-solve ninyo, guys. Tied at 45 apiece. Oh.
Bluetooth mode. Connected.
Been back in the locker room with his son, Mr. Halliburton, confirmed that it is an Achilles injury. Said that Tyrese is doing as well as the circumstances.
Wala, injured si Tyrese. Injured si Tyrese. Achilles injury. What's the answer? So yung tayo na lang natin 21 seconds na lang. Okay, si Caser or Pacers. Doon tayo sa hindi. Wow, Nimhard. From way downtown. 48-47. Achilles injury, ouch. Okay. Okay, si Caser or Pacers. I'm not a fan of any of them, no? Pero I'm fan of basketball. Okay? No? I'm a fan of basketball. I'm not a... Baka sabihin nyo bandwagon, Caser, no? I'm a fan of the game. No? No? And it's fine to root for a team, no? Among them, no? So, para sa akin, I root for the one na, less yung flopping. Just want a really good Game 7. Okay. So, for this one, almost similar lang yung first problem kanina, no? Ito lang ho. Dito, hindi na natin gamitin yung 6M over PD squared kasi hindi na rectangular. No? So, MC over I na. MC over I with M equal to PE. But since the given dito is not the I but the S, M over S. Diba? Yung S is equal to I over C yan eh. I over C. No? So, the initial stress due to the pre-stressing force is negative P over A. So, the P is 820,000 newtons. And the area is 1.4 times 10 raised to 5. Then plus and minus MC over I, no, or M over S. So the M is PE, 820 newtons times 63 millimeters. Okay? And over S, which is both pareho sa top and bottom, 6.8 times 10 raised to 6. Okay? So, if evaluate natin yan, negative 5.857 plus and minus 7.597. No? And again guys, yung sa itaas, tensile yan, positive yan kasi the bending niyan, no? Pwede kang mag-draw. If pwede guys, mag-draw ka. If nag-cut ka dito, due to the tendon placed below the neutral axis, the moment is pa ganyan, no? Negative dito. No? Positive naman dito. Okay? So, the plus dito is sa itaas, the minus is sa baba. No? So, if we're to find the stress at the top, so plus yung gagamitin natin. Kasi nasa itaas eh. No, tensile siya sa itaas. Tensile zone siya due to the eccentric force. No? So, that is negative 5.857 plus 7.597. That's 1.74 megapascal. Okay? Ganun ho. So, the bottom, if we are to solve for the bottom, minus naman, no? And that's negative 13.45. But 1.74 megapascal yung sa itaas. And since the result is positive, then that's tensile. So, 1.7 tensile. Letter A is the answer niya. Okay? Letter A. Now, second question naman is this. Determine the resulting stress at the top fiber of the slab at midspan due to all loads and pre-stress force. Okay, determine the resulting stress at the top fiber of the slab at midspan due to loads and pre-stress force. So dito, i-take account na natin yung 15% loss. No? So, again, gawa tayo ng stress distribution dito. But let's calculate first the total weight kinikerry ng beam, no? So, i-add natin yung weight due to the dead load, then live load, then the, weight ng slab. Okay? The dead load is 2.0 kilopascal. The live load is 2.9. The slab is 2.7 kilopascal. Now, if kilopascal yung given, no, parang pressure siya, to find the uniformly distributed load, multiply ka ng spacing, no? Or the width. Okay, width. And the width is 1.2. Diba? Looking back kanina, A is 1.2. No, so, that's 9.12 kilonewton per meter. Okay, that's the total weight kinakerry ng beam. No, so if we're to find the moment, the same, no, this is still simply supported. So at the midspan, WL squared over 8. So 9.12 times 8 squared over 8. That's 72.96 kilonewton meter. Okay? Now, the stress due to this uniformly distributed load is plus and minus M over S. And since pareho yung S sa top and bottom, no, so we can compute them both together, 72.96 times 10 raised to 6. Okay, ito yun in Newton millimeters. Then over S, which is 6.8 times 10 raised to 6. No, and pwede mo lang hindi na i-include yung 10 raised to 6. That's plus and minus 10.73. No? Now, take note guys, this is moment, no? Positive moment yan, no? The distribution, the moment distribution is like that. It means the direction of the moment is upward, no? If we cut dito sa left side, no? So, tensile, compressive dito, tensile dito, or try to imagine, no, if you're to draw the deflection niya, no? So, compress dito, tensile dito. So, ganun yan. So, i-add natin yung sa baba, i-subtract naman sa itaas. Okay? And since yung pinapahanap dito ay yung at the top, so at the top, yung mag-prevail dyan is yung minus. Di ba? Yung minus ho. No, so, ganito. If include natin yung again yung loss, 1.74 minus 15% of that, or 1.74 times 1 minus 0.15, that's 1.48. No, sa baba naman, the same, negative 11.43. No, and due to the load, plus and minus 10.73. No, due to the load, again, compress yung sa itaas, no? 10.73, negative. Positive naman yung sa baba. So, if you combine natin sila, now 1.48 minus 10.73 is equal to negative 9.25. Okay? And sa baba naman, negative 11.43 plus 10.73 is negative 0.7. So, ito yung stress diagram, guys. Yan. No? Ganun ho, mga kapuso. Ganun ho. Now, part 3 dito is this. Determine the maximum total load, including its own weight, that the slab can be subjected to if allowable stress at service loads are not to be exceeded. So, para hindi daw ma-exceed, ilan daw yung a maximum total load, including its own weight, that the slab can be subjected to. Para hindi daw ma-exceed ito. Okay? So, hindi ito, guys, hindi ito parang additional. Na ipang-calculate natin kung ano yung total niya, na bali, kanina, may nakuha tayong W, which was 9.12. Like, yan. Ilan yung value dito, no? Para hindi ma-exceed yung yung allowable. The allowable are these. 15.5 sa compression, 2.9 naman sa tension. Okay? So top fiber, yung gawin natin, guys, no? Para hindi makalagpas, dapat ganito. This 15.7 15.5 must be greater than the FB, the minus 1.48. Now, i-minus natin yung tension dito, okay? Or negative 1.48 plus the FB, the stress due to the uniformly distributed load. This must not exceed 15.5. Now, bakit I'm making this negative? Kasi I'm making this positive dito instead of negative for compression. Para hindi natin ma-violate yung inequality, no? So ito lang muna yung i-minus natin. Okay, dapat hindi ito makalagpas ng 15.5. So if evaluate natin 'yan, no, i-transpose natin sa kabila. So the allowable stress na pwede nating madagdag is 16.98, no, sa compression. So bottom fiber naman, negative 11.43. Dito, yung positive naman natin tensile. No, compression is negative. Negative 11.43 plus the FB due to the weight, dapat hindi siya lalagpas ng 2.9. So, this FB due to the weight must be less than or equal to 14.33. Now, and since pareho yung S sa itaas at sa baba, no? Top and bottom, S sub T, S sub B, pareho. So, simply choose the safer value nila. And that's 4.8. 14.33. No? So, with that 14.33, equate mo siya to M over S. Okay? So, 14.33 times ds, which is 6.8 times 10 raised to 6. Okay? That's 97.44 kilonewton meter. And equate mo siya to WL squared over 8. That's 12.18 kilonewton per meter. Ganun ho. No? Ganun siya mga kapuso. Or again, as I said kanina, no, pwede kang mag-ratio and proportion, no? So, where to solve for W that corresponds to, or that would give us 14.33 megapascal na stress. Kanina, with the W of, ilan yun? What was that? 9.12. Okay. With a W of 9.12, kunin natin yung stress niya is 10.73. 9.12, 10.73. Ganito yan guys. 9.12, 10.73. I-try nyo daw yan. 9.12, 10.73. Okay? Ilan yung W guys? Open ko muna matpad ko ha. 9.12 over 10.73 times 14.33. Kasi directly proportional lang yan eh. Na 12.18 nga. Na 12.18. Na pwede mo i-solve that way. So instead of going that way, yan. Pwede kang mag-ratio and proportion na lang. No? Sir, bakit naging negative? Naging plus yung 1.48. Okay. Ha? Bakit naging plus yung negative? Or naging minus yung positive? Kasi compression tayo eh. Compression tayo. So, i-positive muna natin yung compression dito. No? Para magamit natin itong less than. No? Or else, malito ka sa, sa exact na inequality to use if you're to follow the negative sign. No? So, i-negative mo muna yung tensile dito. No? While naka-positive yung compression. Okay ba? Nagigets nyo lang, guys? Okay? Nagigets nyo lang ako? Sir, always po ba na sa taas plus and sa baba minus? Okay, guys. Please, wag kayong ganyan, bin, na, always bang ganito? Again, as what I've been explaining, no? It depends on the direction of the moment. No? It depends on the direction of the moment. Okay? Huwag kang ng always ba. Again, if the direction of the moment is like that, no? Maging tensile dito, maging compressive dito. Pag naman yung moment, no, maging minus dito, maging plus dito, wala siyang always, na always bang ganito sa top. Tingnan niyo guys yung direction of the moment. No? Huwag mong sabihin, basta top yan, plus yan, or minus. Huwag ganyan. It depends on the direction of the moment. Please. Para hindi ka malito. The issue for you is nalilito ka. Diba? So, para hindi ka malito, i-draw mo yung moment arm. I-draw mo yung direction of the moment. No? Sorry about that. Okay? Ganon. No? Kayo, ayun kasi, no? Many of you, gusto ninyo na meron lang, i-remember ba na something without really fully understanding why. Gusto mo lang, basta ito, i-plus, basta ito, minus, basta nasaita. Wag, no? Involve mo yung direction of the moment. Okay? Ganon. Hindi yan difficult to do, no? It's not that hard to do, to draw that. Is it? No? And what could cause it to bend that way? Or ano yung may ganyan na moment? Well, yung load. Yung distributed, yung moment diagram like that, no? Positive yung moment dyan. So, ganun yung pag-draw mo. Yung downward na bending na due to the pre-stress yan. Di ba? Ganun. Sir, asa pwede makatanaw live sa NBA game nga libre? Wala na kasing Facebook ngayon, no? Wala na Facebook live, parang na-monitor na ng NBA. Noon sa Facebook lang ako tumitingin eh. Nanonood. Okay ba? So guys, I hope naintindihan niyo lang ako, ha? Yan. Makasabihan niyo ako, ang sungit naman ni sir. Okay. The last problem, no, for this ano. Wait, ano to? Okay. For this topic, no, para mamaya foundation pressure tayo. Ito. Half time pa guys, no, half time pa. Injured si ano pala, start na of the second half. So let's solve this one. So again, last example na tayo for this topic later, though similar, but all about foundation pressure. Oh yeah, no? So this one naman is a bit more realistic and familiar, no? If you've seen precast concrete joints before. No, so we're dealing with a double T section or DT in short. And that's commonly used in long span floor and roof systems. Okay, so here are the section properties, na 2.4, yung A. Now, then the distance from the neutral axis to the top is 103. And the distance from the neutral axis to the bottom, 303. Okay? Then the cross-sectional area is 2.1. Now, the I, moment of inertia, 2.76. So, iba na yung S over Y. Iba na yung S sa top and S sa bottom kasi different na yung Y ng top and Y ng bottom, hindi na siya sa mid-height, no? Yung neutral axis. The unit weight of the concrete is 2.4. Then this DT, this double T, spans 8 meters, no, simply supported. And it is pretensioned with an initial force of 1 to 40 kilonewton from low relaxation strands. The centroid of the strands, centroid nito, is located 220 millimeters below the neutral axis of the DT throughout the beam span. Okay? The loss of pre-stress is 20%. The total uniformly distributed load on the joints are this 4.5 kilopascal for the beam weight included. Live load naman is 3.6 kilopascal. So dito, since sinabi ng beam weight included, na wag mo nang i-calculate yung 24 times the area. No? Kasi sinabi niyang beam weight included. If wala pa yan, if wala, hindi ito included, then the weight of the beam, no, is equal to 24 times the area. No? Pero andyan na eh. Beam weight included. So where to find? First, the stress at the top fibers. Okay, at the end span due to initial stressing force. Stress at the top. Okay, so again, combination yan of the axial and the bending due to the eccentric load na applied at the tendons. Okay, So, ganito ho, yung mga dimension, 2.4, 103, 303. Okay? So, 220 below the neutral axis, yung tendon. So, solving for the first and second part, no? Yung stress is equal to negative P over A plus and minus PEC over I. Siguro, eto, no? If always ba? Always bang minus? Well, minus siya sa normal kasi compression yung effect. Compression yung effect ng, pre-stress due to post-tensioning or pre-tensioning, no? Negative P over A plus and minus PEC over I. Dan depende yan, no? Depende kung saan na portion natin i-consider. Okay, so if doon tayo sa top fibers, we're gonna make C equal to 103. If sa bottom naman, 303. Huh? Okay? So sa top, guys, is this negative 1,240,000 Newton. Ito yon, no, naka-Newton over the area 2.1 times 10 raised to 5, or pwede mong ako actually, guys, I usually do this in my calculator. 1,240 E3 over 2.1 E5. Okay, evaluate it like that sa calculator mo. No? 1,240 E3 na in Newton, it times 10 raised to 3, then 2.1 times 10 raised to 5. Okay? Then, plus and minus, actually sa top, no? Due to the pre-stress, take note, no, yung bending is pa ganyan. Oh, tensile yan. Since nasa top tayo, plus lang. Hindi plus and minus. Plus, MC or PE, M is PE. So again, pwede mong gawin 1,240 E3 times 220. Ito yung PE times 103 na over 2.76 E9. Okay, you may solve it that way. No, you may solve it that way. No, E is yung exponential button, X button beside the answer button. And evaluating that, that's 4.28 megapascal. Okay ba? 4.28 megapascal. Okay, sino yung lamang, guys? Okay. Now, sa bottom naman, take note, guys, at the end span ito. At the end span, no? Due to the initial distressing force. So, hindi natin i-consider yung weight, no? Sorry. Kahit na, no? Kahit na at the bottom, at the mid span. Since sinabi niya initial pa, so hindi pa natin i-consider yung weight, no? So, the stress at the bottom fibers naman, okay, at mid-span is this, no? We simply change this, no? Kasi at the mid-span, na bending at the mid-span is pa ganyan, no? So, sorry. Sa mid-span, pareho lang din. Na yung effect niya is pa ganyan pa rin. So, tensile siya sa itaas, na compressive siya sa baba, and yung C na gagamitin natin is now 303. 303 na po. So, sa bottom, there is negative 1 to 40,000 over 210,000. Minus na tayo. Minus na. And again, the C that we'll use is 303. Now, yan yung mag-change dyan. Now, 1 to 40. Again, the 303 tayo kasi nasa bottom. Not because nasa median, mid span, but because of this, no, being at the bottom fibers. Alright, dito naka-stress daw dito, no. So evaluating that, we can get negative 35.85 megapascal. Sir, paano malalaman na ganyan ang deflection ng moment mo, sir? Depende na ba yan sa pag-cut at saan mo i-consider? Well, if you mean moment due to the pre-stress, it's easy to know, no? Kasi the eccentricity is below the neutral axis. No? So it's clear that the bending moment is like that, no? Now, about the weight naman, I mean, bending due to its own weight, pwede yung direction, the sign of your moment dyan, no? So, for simply supported, positive lang yung moment all throughout the span. Positive lang all throughout the span. Okay? So, yung bending mo is upward. Okay? Or try to imagine the elastic curve niya, no? It sags that way, so tensile siya sa baba, compressive siya sa itaas. Okay? Or ito lang, no, kung ano yung sign, no, yung positive bending kasi guys is pa ganyan. Yun yung positive bending if dyan tayo mag-cut. If dito naman tayo mag-cut, no, if dito tayo mag-cut, yan naman yung positive bending. If it makes the beam smile up, no, if it curves up, positive yung bending na yan. Okay? Ganun ho. Look, dapat 2.76. 2.76 pa rin yung ano dito. Wait, i-edit ko guys, no? I-edit ko. Dapat 2.76. Ilan yung maging sagot? Ilan yan? If 2.76 ito. Ilan? Ah! Sakit ng chan ko guys. 1 to 40,000 over 210,000 minus 1 to 40,000 times 220 times 303 over 2.76. Negative 35 point, pareho lang, no? Pareho lang yung result. Typo lang yun. Okay? Typo lang. Same lang. Now, sa third question na tayo. Sa third question, compute the resulting stress at the bottom of the double T at midspan due to service loads and pre-stress force. So, if we calculate natin yung total weight niya guys, so that we could compute the total moment, ipang-add lang natin yung dead load, live load. And again, wag mong gamitan ng factors, no? No, wag mong gamitan ng factors. So, ito ho, W is equal to 4.5 kilopascal. Multiply mo ito ng width niya. The width is equal to 2.4. Okay? So, ganun yan guys, no? If given yung pressure, no? Ilan yung spacing, no? The W on that is equal to the weight in kilonewton per meter is the pressure, okay? Times the spacing. Okay? Pressure times the spacing. Ganun ho. No? Para maging kilonewton per meter. Okay? If i-times length kasi mo ito, P times S times L, that's the total force. No, so, dapat na kilonewton per meter, P times S lang. No, so, 4.5, included na yung own weight dyan, no, plus 3.6 times 2.4, that is 19.44 kilonewton per meter. Okay? 19.44. No, so makalculate na natin yung M at the midspan. Again, WL squared over 8 lang yan kasi simply supported lang, no? O may nagtanong dito, sir, ano yan? May time po ba na hindi yan simply supported? Of course, meron. Like, pwede siya fully fixed beam. No, but mostly simply supported yan eh. No, dyan ina-apply yung ano, kasi sobrang haba ng beam. No? Sobrang haba ng beam. Na-apply siya sa mga simply supported beam. Okay? Kasi ito usually mga precast concretes ito, no? Precast high tension prestressed concrete, no? So ano lang ito? Parang transport lang ba, no? So minsan nakapatong na yan, so naka simply supported lang sila minsan. Okay, so 19.44 times 8 squared over 8. So that's 155.2 kilonewton meter. Okay? And your stress at the top is equal to what? Stress at the top fiber. Take note, no? Compute the resulting stress at the bottom of the DT due to service loads and pre-stress. But if we are to solve for the stress at the top, that's equal to negative my at the top over the moment of inertia. Na bakit? Again, compressive sa itaas. No? Compressive sa itaas. So, y at the top yung gagamitan. 103. No? But since we're to solve for the F at the bottom, no, dapat positive tayo. No? Ganun yung direction for the load na tayo ha. Load na yung kine-consider dito due to the loads. So, positive na. Y at the bottom over the moment of inertia. Y ng bottom is 303. 155.52 times 10 raised to 6 times 303 over 2.76 times 10 raised to 9. Okay? And that is 17.07 megapascal. No? 17.07. Now, since i-compute yung resulting stress, dapat i-superimpose natin, but dagdagan natin i-consider natin yung 20% loss. Okay? So, again, ito yung stress distribution. No? Sa itaas, 4.28 megapascal sa top. No? So, 3.42 yan if bawasan ng 20%. Sa bottom naman, bawasan ng 20%, maging 28.68. No? So, ito yung distribution niya. Compressive dito, tensile dito. And due to the weight, no? So, due to the weight, the top has negative stress. Negative 5.804. Sa baba naman is tensile, positive. Okay, then i-add natin sila. So this will result to negative sa itaas, negative 2.38 megapascal, and dito naman, negative din, negative 28.68 plus 17.07, negative 11.61. No? So, ito yung sagot, no? Negative 11.61 megapascal, and compressive yan. No? Compressive yan. Okay? Yan. Ganun ho, mga kapuso. Any question? Okay, so mag-break tayo, no? Mag-break tayo and balik tayo later at 10:20, no? BRB 10:20 AM. No, mag-breakfast muna ako, then if I still have time, i-upload ko no yung PDF. Okay, last week. No, if hindi makaya right after the class, no? I cannot do live stream. I tried, no? Hindi magla-live stream. Kaya ma-detect ng ano? Ma-detect ng hindi niya kayang i-live stream yung game. Oo, meron silang ano na hindi ma-live stream. Okay? Sir, sali mo sa dasal. Nakasalalay pang refresher ko. Pag sure, oy. Pag sure mo diha. Okay. Okay, eto. Sir, tanong ko lang po saan nga po galing yung 2.4 na minultiply sa DL. Ano yan? Spacing yan. I mean with. Yung with. 2.4. Okay? Yung A ba kanina? Yung A. Saan daw galing yung 2.4? Galing yan dito, guys. Ito. No? Yan ho. Okay? Hala. So, again, break muna tayo. Gutom si sir. Nagugutom ako sa mga tanong nyo, guys. No? Okay, mamaya, foundation pressure tayo. Hala, sige. Break. Sound check. Hello. Okay, let's continue. Andyan pa ba kayo, guys? Sir, kaya din po ba yan ratio and proportion? Okay, guys, again, no, this corner ba supposedly is intended or reserved for me, no? If meron ako yung post dito. Dito kayo sa students corner. Okay. Yan. Kaya din po ba yan ratio and proportion? Didn't I solve that kanina? Compute the resulting stress. Wag, hindi na siya ratio and proportion. Unless if pinapahanap yung yung additional weight or total weight for that certain stress, no? Okay, sige. Let's proceed to our next topic. Ito ho. Sir, post ni mo na sa website. Yes, I will, no? I promise you, I will post it sa website. So, dito naman tayo, guys. Okay, dito naman tayo sa foundation pressure. Okay? So, ito yung next topic natin, no? So, still related sa concepts na ginagamit natin sa stress calculations, no? But this time, we'll talk about soil bearing pressure, no? Or foundation pressure, no? The idea is just similar, very similar. It follows the same principle we used in axial plus bending stress, no? But applied in different contexts. Sa mga beams, we analyze the stress across the sections. Compression on one side, tension on the other. And in soil bearing, we do something very similar. No? We're analyzing how the load from a footing or foundation is transferred to the soil below. Okay? It's transferred to the soil below. No? So, ito yung formula. Okay? If, let's say, the foundation is carrying, the footing is carrying load P, ano talaga yung throat ko, guys? Muna. Okay, so if a footing is carrying a vertical load P, the stress distribution niya is ganito, no? Just P over A. Now, dito, i-positive natin yung compression, no? I-plus lang natin since mostly compressed yung stress, no, sa soil. Okay? And if meron ding bending moment, okay, about the neutral axis, no? So, the stress distribution is ganito naman. No? Due to bending moment. So, that is MC over I. MC over I dito sa compressive side. MC over I naman dito sa tensile. So, parang baliktad na, no? Yung compression zone, MC over I, yung tensile, negative na ngayon. No? So, makikita natin dito na if i-combine natin, no, the stress dito sa portion 1, section 1, no, or point 1, Q1, and that's the sum of these two, P over A plus MC over I. Then sa Q2 naman, P over A minus MC over I. Ito yung stress distribution niya. No? So, P over the area plus and minus MC over I. Sa Q in, Q maximum, that's at the Q1. Positive yung gamitin natin. Q2 naman negative. So, dito guys, again, ulitin ko. No, i-take natin na positive na yung compression side. Okay? positive na sa compression side. Ganun. Ito yung formula. So, the moment of course should be dyan, no? Kung ano yung moment about the centroid of the footing or the neutral axis, that is the axis of bending. Okay? Pwede kayo mag-screenshot. Then, if ever the dimension of the footing are B by L, now width is the length L, and the length is B, okay? So, the formula becomes ganito. P over BL is plus and minus 6M over LB squared. Okay, P over BL plus and minus 6M over LB squared. No? Ganun ho. Now, if walang given na moment, but merong eccentric na load P, na hindi siya applied at the center of the footing, then may eccentricity siya, now equal to PE. No? So the formula, from 6M over LB squared, maging 6PE over LB squared. Ano siya? Cute ng baby ko. Okay. So, if i-factor out natin yung P over BL, the formula becomes ganito, no? Q is equal to P over BL times 1 plus and minus 6E over B. Okay? Q is equal to P over BL times 1 plus and minus 6E over B. So, again, positive if doon tayo sa direction of the bending, no? Most compressed portion sa right side dito. And the other side naman, negative. No? Ganun ho. Okay, now, if ever, merong retaining, if merong retained soil na dito, na supported by this retaining wall, na then, i-calculate natin yung soil bearing pressure below the footing. Dapat take into account mo lahat ng weight, no? So, i-ano mo dito yung weight of this retaining wall, weight of this lateral earth pressure caused by the soil. Sound check. Naka-mute ka. No, hindi ako naka-mute. Oy, naka-on ito. Baka ikaw yung naka-mute. Naka-mute daw ako, guys. Na-disturb ako. Oy, kanina pa ako nagsimula. Ngayon, iba, hindi naman nagreklamo. Naka-mute daw ako. Baka ikaw yung nakamute. Okay, sige. So, again, no, if merong ganito, i-determine mo yung total vertical load apply dito and moment about the center of the base or the neutral axis of the base, now, so that you could determine saan mag-act yung resultant niya on the soil. No? So, i-determine mo kung ano yung location of the resultant, no? And that is equal to E, and that E is equal yan to M over P. Okay? M over P. Yung M, again, i-calculate mo yan based on the moment about the center of the base. No, so that includes the moment caused by all the loads applied, including the weight and as well as the active soil pressure. No? And then after mo ma-solve yan, no, i-add mo lahat ng vertical, then determine mo yung moment, no, and kung ano yung vertical load, yan din yung resultant force dito sa base, no, upward resultant force, no. So that acts at a distance A equal to M over P. Okay? Ganun yan. Now, if ano naman natin yan about the toe of this foundation or footing is dito, no? Dito yung toe. So, about the toe, there's what we call righting moment, no? Meron din tayong tinatawag na overturning moment. Righting moment is like is also resisting moment, no? The overturning moment, yan yung moment caused by the weights of the soil, the active pressure, and so on. Now, while the righting moment naman is the resisting moment caused by the weight of the foundation itself, and that may into the soil, no? The overburdened soil dito. Okay? So, if ma-determine mo na yung RM and OM, we can determine the location of this R that's at distance barred X, now from the toe, and that's equal to RM minus OM over R, di ba? If mag-moment tayo about the toe, no, RM minus OM is equal to, no, equilibrium natin, no, is equal to R times barred X. So that's why maging ganyan yung equation. Okay? And yung E is equal yan to half of the B, no, kasi the center is B over 2, so B over 2 minus barred X. No, so E is equal to B over 2 minus barred X. Okay? So, ganun yan. No? Now, let's talk about gross and net foundation pressure. Foundation. Okay? So, ano ba yung gross pressure? Ano ba yung net bearing pressure? Okay, so importante ito lalo na kapag may surcharge na or may soil fill on top of the soil, no? Like ito yung distribution, no? So considering the loads only, no, from the ano yan, either the wall, no, or the column, no, and also the footing, the distribution niya is ganito. Now that is the net pressure. Now if hindi natin isali yung overburden pressure at saka surcharge. Okay? Now, of course, no, yung footing is ano yan? Backfilled yan by a soil, no? So pinapatungan niya ng soil. No? So meron siyang weight na i-carry, no, and meron ding surcharge, no? And due to this weight of soil and surcharge, merong idagdag, no? So due to the weight of the soil, we call it the overburden pressure, no, and that includes the weight of the soil and the surcharge, no, and the gross naman, the net, the effective niya is the sum, no, or the total niya, the total is the sum of the net pressure and the overburden pressure. So maging ganito yung gross pressure niya. Okay, so due to all the loads na yan, no, and ito, must not exceed allowable soil bearing capacity. Now, in calculating or considering the soil bearing capacity, yan yung i-consider mo. No? Yan po yung i-consider mo. So, hindi pwedeng negative yan for bearing on soil. No? In the design of footings for shear and bending, the net pressure must be used. Okay? So, in designing the footing, okay, like kung ilan yung reinforcement needed, no? Pagdating natin sa RC, no? Discuss yan ni Sir Tariga ninyo, no? Kung ilan yung needed na reinforcement, so net yung gagamitin. But for soil bearing capacity, dapat yung gross yung gagamitin. Okay? Ganun po, no? Yung surcharge, ano ba yan? It's a geotechnical and foundation engineering term, no? It refers to any additional load acting on the ground surface near on the top of a foundation. Okay, so it may be an extra weight or a concrete pavement or stockpiled materials, so mga gravel, soil, construction materials, or another layer of soil fill, no? Or even nearby traffic of or structures, no, pushing down on the soil surface. That is considered the surcharge. Okay? So, ganun po yan. Okay? So, I hope gets lang, no? Now, if ever guys, the vertical load of the footing no acts along the ano lang neutral axis or center of the footing, no, then uniform lang yung distribution of the soil pressure. No, the Q is just P over BL. No? So there's no uplift dyan. Okay? But if ever eccentric yung load, no? With E equal to B over 6, less than B over 6, no? Then the distribution of the soil pressure at the bottom is ano lang, trapezoidal lang. Okay? Trapezoidal lang ho. No? Pero if lagpas naman siya, the formula in calculating the Q is this. P over BL, 1 times 1 plus and minus 6E over B. No? But, yung ax naman dito is lagpas 1/3 of B. No? From the toe. Wala ding uplift dyan. Pero if lagpas na siya, if exactly na siya at B over 6, no? Then, exactly triangular yung stress distribution with 0 at the other end, no? Maximum at the toe, no? And the Q niya is equal to 2P over BL. Okay, 2P over BL kasi triangular na yan eh, no? Like, if i-calculate natin yung total resultant ng distributed load dito, that's 1/2 of Q times the length. Now, length is the, area doon, times the base. Or Q times base times the length. No? I-equate mo yan to R. No? So, R, yung Q is equal to 2R over BL. So, maging ganyan yung formula. No? If exactly B over 6 yung, yung E. Okay? Upon calculating M over P. No? Ganun ho. Now, if ever naman, the E exceeds B over 6, okay, if lagpas siya ng B over 6, then the formula becomes ganito, the Q max becomes 2P over 3 Bart X times L. No? Diba guys, in hydrostatic force, remember, no? Hydrostatic force, discuss ni Sir Duaso ninyo, no? If ever the water pressure is andito lang, sorry. Ma-zoom in pa ito. Ever the water pressure is andito lang, no? The stress distribution niya is ganito, no? And the load is acting dito at a distance 1/3 from the base, 1/3 of the height from the base, no? Now, if 1/3 yan, no, 1 over 6 naman to. 1 over 6. 1 over 6 of the height. Okay, 1/2 minus 1/3 is 1 over 6. Okay? Now, if maging trapezoidal yan, no, yung soil distribution, that will happen if the depth of water is is way above the top of the rectangular footing. Say, ito yung rectangular pressure, or ito na lang be white. Ito yung distributed, ito yung plate, ito yung ito yung top water surface. The stress distribution is like that, no? Ito yung stress distribution, hindi natin isali ito, no? Ito lang. Okay? And if kunin natin yung resultant nito, no, yung resultant niyan acts dito, no, with eccentricity E, I know you know the formula, no? Diba? Ano yung formula niyan? I over A bar Y, di ba? I over A bar Y. No? Yan ba yung formula? No? Now, yung value na ito is always less than B over 6 or H over 6, height over 6. Okay? If this is the height of the water. No? Ganun ho. Ganun. Okay? So, magkataon lang yan na lalagpas ng H over 6 if ito yung rectangular plate mo. If hindi siya fully submerged, no, hindi siya fully submerged, imagine this. No, the soil distribution, the water distribution mo, pressure distribution is like that, no? And yung pressure na ito, no, is lagpas na yan ng B over 6. Lagpas na yan ng B over 6. Okay? So, ma-relate natin dyan. No? So, ganun ho. Okay? And, ma-determine natin, no? Yung value nito by first calculating the barred x. And the barred x is equal to B over 2 minus E. No? B over 2 minus E. Okay? Diyan nag-act yung yung resultant, and then after that, pwede mo na makalculate yung Qmax, no, using that formula. So, again, the same kanina, no, like yung gawin natin, area is 1/2 Qmax times this, which is equal to 3 times barred x. 3 times barred x lang yan, then times the length equal to the R. So, if we would solve for the Qmax, that's equal to 2R over 3 barred x times L, no? So, the formula becomes ganito. Okay? So, in this case, guys, meron na itong uplift, no? Meron ng uplift. Okay, ito wala, no? Ito wala. Ito meron ng uplift, no? Ganun. So, ito yung solution. Okay? I mean, derivation. No? And 13 points yung lamang under 2 minutes, no? So, most likely, champion na talaga yung Oklahoma City Thunder. And ball position niya pa nila under 1 minute. Panalo na, guys, no? Panalo na yung Thunder. No? Para sa akin, parang so difficult na yan. Though it's still mathematically possible, no? Pero hirap. Hirap niyan. So, that's it, mga kapuso. Yung R is equal to P, no? So, 2P over 3 barred x times L. Example tayo. Yabo na ang pang-refresher. Yabo na ang pang-refresher. Eto. Given the following data of rectangular footing shown, column loads 600 kilonewton yung P, 80 kilonewton meter naman yung moment. Then unit weight of the concrete is 24 kilonewton per cubic meter. Unit weight of soil is 18 kilonewton per cubic meter. Okay? So, compute the maximum net soil pressure in kilopascal. Okay? Maximum net soil pressure in kilopascal. So, paano yan? Last half a minute na lang, guys. Tingnan ko muna, guys, ha. Wait muna. Na-distract. Last 8 minutes na lang. Sige lang. Champion na talaga yung Thunder. Last half a minute na lang, guys. Sige na lang, balikan ko na lang yan. Anyway, so to compute the maximum net soil pressure, yung gawin natin is i-determine muna natin if ilan yung E. Start ka dyan. Okay? If given yung P, given yung M, i-calculate mo yung E. No? Ilan yung eccentricity. No? If i-check natin if lagpas ba ito ng B over 6 or hindi. No? So, M over P lang yan. Okay, M over P is 80 over 600 equal to 0.133. No? Now, ano ba yung B over 6? B over 6 is equal to 0.417. Okay? 0.417. So, maliit lang. No? Maliit lang yung E, no? Compared to B over 6. So since maliit lang, hindi siya lagpas, then this is just trapezoidal. No? Trapezoidal yung soil distribution. Okay? So yung QNet is equal to P over BL, no, it's P over the area, times 1 plus and minus, P over BL plus and minus 6M over LB squared. Okay? Pwede natin i-solve na lang that way, no, since meron namang M, no? So, P over BL is the area, is the normal stress plus and minus 6M over LB squared, bending moment stress. So, 600 over the area, 2.5 times 2, kilopascal mo lang to, kilonewton per meter squared is kilopascal. Okay? Then, plus and minus 6 times 80, kilonewton meter, now over 2 times 2.5 squared. Okay? So, champion na nga, no? 6 times 80 over 2 times 2.5 squared. No, dapat ha, kung ano yung B, ano yung direction of bending, yan yung, square mo, no? Yung length, hindi. So, evaluating that, that's 120, no, this is 120, plus and minus 38.4. 38.4 megapascal. Okay? Ganun. So, sa maximum, no, QNet max, that's 120 plus 38.4, that's 158.4. Okay, dito yan. No, dito po yan. Okay? Now, the overburden pressure naman, that is the pressure caused by the soil, that's 24 times, caused by the soil and also the footing, 24 times 0.6 plus 18, ito yung gamma ng soil, no? Times 1.2. Para bang pressure dito, no, considering this gamma H. No, ito soil, ito concrete, no? So 24 times 0.6 plus 18 times 1.2, that's 36. Okay? Yan yung overburden pressure. Now, that's 36 kilopascal. Then yung gross Q is the sum lang nila, no? 158.4 plus 36. Now that's 194.4. Now if we're asked to find the maximum gross soil pressure, okay? If gross yung pinapahanap. But of course, the answer dito is the Q net max na ito, 158.4. Okay lang ba? Na madali lang siya. Ito yung sagot na sa pangalawa. Wait. Maximum gross soil pressure in kilopascal. Yan yung sagot sa ano? Sa wait, parang may ano yung slides ko. Wait mo na ha. Ito yung maximum gross pressure, 194.4. Okay, sorry. This is the other way pala to solve it. No? The other way to solve this is by calculating the moment about the toe. No, moment about the toe. No, the writing moment and the overturning moment. No? The writing moment and the overturning moment. So, dito, walang writing moment, no, walang lateral load. Okay? So, ganito, yung i-calculate natin, weight ng foundation. So, weight ng foundation is 24 times 2.5 times 2 times 0.6. Ito yung weight nito. Weight of the footing, Weight of the footing. Yan. 72 kilonewton. Na weight naman ng soil, yung weight ng soil, okay, is equal to 18 times 2.5 times 2 times 1.2. Okay? 18 times 2.5 times 2 times 1.2, that is equal to 108. No? So, ito yung total weight that acts dito. No? Downward. Then, if i-calculate natin yung R, that R is equal to the sum of P, the W of the soil, weight of the soil, and weight of the footing. No? So, that is equal to 600 plus 108 plus 72. No? And evaluating that, that's 780 kilonewton. That is the R. No? Now, the righting moment or the resisting moment, equally yan to the sum of this, since vertical lang ito lahat, no, at the neutral axis. So, multiply mo lang yan ng B over 2, kalahati nito. No? Ito yung righting moment. No? Ito ho. No? And that is equal to 108 times, 780 times B over 2, 2.5 over 2. No? 780 yung sum nila. Take note. Ito, 780. So, times 2.5 over 2. Now, that's 975 kilonewton meter. Ito yung righting moment. Now, ano ba yung overturning moment dito? Actually, wala. No, the overturning moment is... The overturning moment is the moment. Ito. Moment na ito. That's 80 kilonewton meter. No? Yan yung overturning moment. No? Sorry for saying wala. No? Meron 80. So, yung bar X natin, kung saan na-locate ito, is equal to RM minus OM over R. No? So, that is 975 minus 80 over 780. That is equal to 1.147. No? Yan yung bar X. Okay? And, yung E natin is B over 2 minus bar X, or 2.5 minus 2 over 2 minus 1.147. So, 0.103 yan. And i-compare mo ito if lagpas ba ito ng B over 6, no? But again, lagpas yan. No, lagpas yan ng... hindi yan lagpas. No, less than lang yan ng B over 6. Okay? So, after that, i-calculate mo yung Q this way. R over BL, no? R naman yung gamitin mo in calculating the gross. Okay? R over BL. No, which is the sum of P, the WS, and the weight of the footing. So, 780 over 2.5 times 2, then times 1 plus and minus 6E over B. No, so that is 194.56 megapascal. Okay? So, yun ho, mga kapuso. Okay? At watch muna tayo sa celebration nila. Awarding na sila, guys. Doon na lang ako sa first solution ng gross additional lang. Oo, yeah. Actually, I preferred the solution kanina, no? Ito medyo mahaba na paraan. No? Mahaba na paraan po. Let's see kung sino yung ano yung MVP? Parang klaro na, no? Si Shai, SGA. Now, yung pangatlong tanong naman dito, if the allowable soil pressure is 165, determine the minimum width B in meters. If the allowable daw is 165. Now, for this guys, gross yung gagamitin natin, no? Gross. So, dapat gross max is 165. No? 165 kilopascal. Okay, so dapat it's less than or equal to 165. Okay, so it comes from this, no? P over BL plus 6M over BD squared or LB squared. Okay, plus 36. Okay, then 600 over B times 2 if B is yung unknown. Okay, plus 6 times 80 over 2 times B squared plus 36. Dapat less than or equal to 165 ito. So, ito na lang, no? Mas madali ito na paraan. Diba? Mas madali yan na paraan, no? So, minimum B is 2.96. Okay? So, if yan yung sagot, of course, the longer the better. No? The longer, the better. So, B is equal to 3 meters. Ganun lang ho. Ba't umiiyak yung baby ko? Wait mo na guys ha. Umiiyak si baby kasi talo yung ano. Oh, nasa used to na si KD, no?
Homegrown, very special. Sam Preston, Coach Dagnoff, and this amazing team. Congratulations, 2025 NBA champion.
Okay, next problem. Nadidistract sa ano, championship. Okay, dito naman tayo. 300 millimeter thick concrete wall is to be centrally located on a footing. The allowable soil bearing pressure is 192 kilopascal. And consider 1 meter length of wall footing. Okay, consider 1 meter length lang ho. No? Now, ito yung first question. The footing is to be designed for a moment of 180 kilonewton meter. Okay? And a total vertical load of 360 kilonewton meter. What should be the minimum footing width to prevent uplift? Okay? Diba, meron siyang uplift if yung A natin is lagpas ng B over 6. Sobrang layo ng ng resultant. 'Di ba? So dapat hindi lalagpas ng B over 6. Okay? So ito yung B, no? I-consider natin is 1 meter length of the wall footing. Na dito na nag-a-apply yung yung moment at saka ano tawag dito? Vertical load, no? Vertical load na 360 kilonewton and moment na 180 kilonewton meter. Alright? Ganun. Now, to prevent uplift, dapat less than B over 6, no? So, dapat B over 6 or yung part X is dapat greater than B over 3. Now, again, as napakita ko kanina, no? Na magiging trapezoidal siya if yung center of pressure is nandito at a distance less than B over 6, no? B over 6. So if we're to solve for B, dapat 6 times E. Now, yung E natin is equal to M over P. So, 180 over pwede, ganito, no? If M over P is to be less than or equal to B over 6, then dapat B is greater than 6M over P or greater than 6E. No? Greater than 6E. So, 6 times 180 over 360, that is equal to 3 meters. Now, that's the minimum. Now, minimum width, no, so that there is no uplift. Okay? Nasudip pa? Nasudip pa na akong baby. Okay. Next naman.
For the first time
Okay, wait mo na guys ha.
Same player, the regular season MVP, scoring title. Now his finals. Maybe Alexander.
Okay, si SGA, Finals MVP. Okay. Sige. So, dito naman tayo sa part 2. Part 2, given a total vertical load of 540 kilonewton. Wait, i-adjust ko muna to guys, no? So, part 2, yan ako muna to. Yan. Yan. Okay. So, sa part 2, focus tayo dyan. Yan. So, given the total vertical load 540 kilonewton and the resisting moment is 1,120. The resisting moment is about the toe na RM. Okay, 1,120 kilonewton meter. The footing width is 4 meters. How much is the allowable overturning moment such that there will be no tensile stress in the footing? Okay. So, para walang tensile stress on the footing, again guys, no, may tensile yan if merong uplift, no? So, dapat para wala, dapat pure compression dyan, no? So, para walang uplift, dapat E is less than B over 6 or barred X is greater than or equal to B over 3. No? So, ang i-determine natin, allowable overturning moment. So, ito yung gawin natin. No? I-calculate natin yung overturning moment using the formula barred X is equal to RM minus OM over R na dapat greater than or equal to B over 3 ito. No? Na yung R natin, that is just equal to the P. Okay? Equal yan to P. No, 540 kilonewton. No? And writing moment given, so RM 1,120 resisting moment minus OM overturning moment over 540. Dapat this is greater than or equal to 4 over 3. No? So, if i-solve natin yan guys, no, yung OM must be less than. No, if i-solve natin less than or equal to 400 kilonewton meter. So, the maximum is 400 kilonewton meter. No? Yan yung allowable na overturning moment. Okay? Kasi if lagpas yan, let's say 500 yung overturning moment, no? Then there will be uplift, so there will be tensile stress on footing. No? So ganun ho, mga kapuso. What's wrong with my baby? Why you cry again? I know. Mel cried. Okay, now, ano naman yung pangatlo? Yung pangatlong tanong, yung pinapahanap naman doon, wait muna. Adjust ko lang muna. Okay. So yung pangatlong tanong is given the resisting moment 955, overturning moment 325, and the total vertical load is 450, and the footing width is 4.2. which of the following gives the maximum soil pressure? Okay, now, to solve for that, now, the RM, the vertical load is 450. Now, about the toe, the resisting moment is ito, no, 955 kilonewton meter. Now, the overturning moment is 325. So, with this given, guys, makalculate natin yung barred X. Again, using the same formula. Now, that is RM minus OM over R. Now, R is equal to that 450. So, 955 minus 325 over 450, that is equal to 1.4 meters. Okay? 1.4 meters. Now, ang B over, ang B over 3 is 4.2 over 3, 1.4, no? So, the same sila, no? Or, if i-calculate natin yung E is B over 2 minus barred X, that's 4.2 over 2 minus 1.4, that's 0.7, and this is also exactly 4.2 over 6. Diba? 4.2 divided by 6 is equal to 0.7. So, exactly the same sila. No? Exactly the same. So, ibig sabihin yan, exactly triangular. Now, triangular yung soil distribution with 0 at the other end. No? So, the soil distribution is ganito. 0 siya at this end. Okay, so, yung Q dito, no, pwede natin gamitan ng formula, yung R over BL times 1 plus and minus 6A over B. No, yun yung formula. So, substitute natin 450 over 4.2 times 1 times 1 plus 6 times 0.7 over 4.2. So, then we can get the Q equal to 214.3. Q yan dito, guys. No, Q yan dito. But the other formula that we may use is this. No, if ever the same, no, B equal to 6 over B over 6 and X, barred X equal to B over 3. That's 2R over B times L. No, and the same yung magiging result nito, 2 times 450 over 4.2 times 1, and that's 214.3 kilopascal. Okay? Again, pwede mo lang ma-derive yan. R is equal to 1/2 Q BL. No? 1/2 Q BL. Ganun ho. Okay ba? So, that's the answer. No? Easy lang ba, guys? Easy lang, no? Ano mo na siya? Be, ambisa na siya, be. Adjust. Agreed.
Yeah.
Hello, guys. With Daddy. Okay. Discuss na si Daddy, ah. Okay. Okay, next example naman ito. Rectangular footing is 2.5 meters along the y-axis and 3 meters along the x-axis. The footing supports a concrete pedestal. The top of the pedestal is subjected to a vertical force of 1,500 kilonewton. And a horizontal force of 153 kilonewton acting along the x-axis. Okay, so ito yung figure. Okay. If isa-isahin natin, rectangular yung footing, no? So, rectangular yung footing, 2.5 meters along the y-axis So if when we say along, no, when we say along, papunta yan dyan, okay? Along, no? Towards that direction, along Y, okay? So 2.5 yan, and 3 meters along the X. If ito yung X, along the X, okay? So, ganoon yan, guys. No? Now, this footing supports a concrete pedestal, no? So this is the pedestal. Okay? And merong vertical force na 1,500 kilonewton at the top. Okay? And then 153 kilonewton naman along the x-axis. Okay? Mas pogi pala si Matt kaysa kay na-burp na. Burp? Nice. Kaysa kay Daddy. Oh, of course. No? Pero kamukha talaga ito sa akin, no? Talata, mama? Mami. Na-burp na, mami. Ay. I have a wonderful life. It's like I'm the richest man in the whole world. Okay. Ngayon, sir, gets na namin. Pero kapag may example na bibigay, sir, mawawala na. Okay, so. Sabi dito, no? The footing thickness is 700 millimeters. Okay, ito yung footing, no? 700. Buti nagmana sa mama, sir. Hindi, sa akin yung nagmana. 700 millimeters. The depth of footing is 2.2. Okay, so the depth is 2.2. The distance from the top of the pedestal, yung depth is up to dito yan. Na up to the bottom yan. Okay? The base 2.2 ito. Now, the distance from the top of pedestal to the base of footing is 2.5. 2.5 naman to again. Yung base ng footing, center of the footing, yung vertical distance niya is 2.5. Okay? Ito. No, so, if i-determine natin how high is the soil above the footing, that's equal to 2.2 minus 0.7. No, 2.2 minus 0.7 equal to 1.5. Okay? Okay, so, where to find the unit weight? No, unit weight are given. Where to find the maximum net soil pressure in kilopascal? So, if net lang, due to the applied loads lang yung i-consider natin. Okay? Ganon. Then second, compute the required soil bearing capacity. Okay? So, ganito lang ho. Ganito lang, no? First, ma-determine natin dito ano yung moment, no? So, gawin natin that this force acts dito sa center of the footing, no? 1,500 kilonewton, and the moment naman about the neutral axis, about y, no? So, ito ho, that is the moment caused by the 153 kilonewton force, no? So, yung moment na yan, equal yan to this horizontal force or lateral force na times this moment arm na distance of this about from the base, above the base, no? So that is equal to 153 times 2.5. Okay? That is equal to 382.5 kilonewton meter. Now yung E natin dito, guys, is M over P again, no? So 382.5 over 1,500 equal lang yan to 0.255. Okay? 0.255. Now, what is 3 over 6? 3 over 6 is 0.5. Sorry. Is that correct? Oh, 3 over 6. No, the B over 6 is 0.5. Okay? So, this value, 0.255, is less than 0.5. No? Less than siya 0.5. So, the soil distribution, the soil pressure distribution is ano lang, trapezoidal lang, no? Simple lang ito. Mas madali ito if less than b over 6, no? So merong Q maximum, meron ding Q minimum, no, kumbaga. Now, yung maximum, yung net maximum is in the formula P over LB, no, the normal stress plus 6M over BD squared over LB squared. So this is equal to 1,500 over 2.5 times 3, then plus 6 times 3, 2.5 times 2.5 times 3 squared. Okay? 6M over LB squared. No, yung L is ito, yung B is ito, no? Ganun yan, no? LB squared. Okay, parang BD squared ba sa rectangular beam, 6M over BD squared. The depth, yung square kasi the moment is about that, no? So, evaluating that, guys, that's 302 kilopascal. No, yan yung maximum net soil pressure. Yung gross naman, okay, di ba, yung naalala ninyo, no? Idagdag lang natin yung overburden pressure. The overburden pressure will be caused by the soil above niya and also the footing itself. No, gamma H lang yung idagdag natin. So 302 kilopascal, dagdagan natin ng concrete, 23.5 times its thickness. Now, concrete has a thickness of 0.7. So 23.5 times 0.7 plus due to the soil naman, the height of soil is 1.5. So 17.5 times 1.5, no? And evaluating that, ito naman yung makuha, 344.7 kilopascal. Okay? Ay, baby, so cute. No, gusto niya nang magsalita, guys. No, gusto niya nang magsalita talaga. Pero yung sagot dito, no, for the first part is ito, 302. No? And dito naman, yung allowable is this gross, no? Ito yung allowable soil bearing pressure. So 344.7 kilo pascal. Okay? Okay, so that's it. May mga tanong kayo? Sige daw eh. Ano yung mga tanong nyo? May mga example dito na parang andali lang, no? Kasi lang, i-follow ko lang itong mga example dito. Now, may practice problems din po. Maghingi ako ni Sir Tariga, no? And also mag-compile ako. Okay. Hindi ko pa nadala sa oras, no? Binigay lang kasi sa akin to nung Friday. Sige lang. Baka meron si Sir Diego, no? And also si Sir Tariga ninyo, no? Sa kanila yung topic na ito eh. Okay. Dito naman tayo, guys. Ito naman. The footing shown is subjected to the following column loads. 900 kilonewton, no, sa column, and also moment 570. Now the center of the column is 1 meter 1 meter from the short side of the footing. So yan yung 3D view niya. No? Then determine the maximum net soil pressure in kilopascal. Okay? So the column itself is eccentric, no? Hindi siya concentric with the footing. Opo, malaman. Ano yung tanong? which length ang naka-squared sa pound squared? Hindi ko gets yung tanong. Sige lang, balikan ko yan, no? Now, in this case, guys, the column is there, no? Hindi siya concentric with the footing or hindi siya with the same center of the footing. No? So, if we determine natin yung moment niya about its neutral axis which is there, no? Sa gitna. Okay, center of the footing. Ay, ito pala, no? About y. Yung mangyari dito is since nasa left side yung column, yung effect ng moment niya, yung eccentricity niya is to the left. So, isasubtract natin yan. Yung moment about the base, if we calculate natin how far is that from the center, diba, 1 meter ito, 3 meters yung length, or yung length ito, kalahati is 1.5, so 0.5 yung distance na ito. 0.5, no? So, if i-transfer natin sila dito, no, the load acting at the center, no, vertical, and the moment is equal to this. The P is the same, 900 kilonewton, but the M is hindi na. No, that is equal to 570 kilonewton meter, then minus tayo ng 900 times 0.5. Okay? Bakit? Kasi ano yan, nasa left yan eh, no? So, 900 times 0.5. So, 120 yung moment niya about dyan, no? 120 kilonewton. P is the same with P sub C, that's equal to 900. No? So, in calculating the net maximum pressure, balay pareho na lang kanina. M over 6, M over P, i-calculate mo, that's the E. No, then i-compare mo what is B over 6. B over 6, 3 over 6 is 0.5, so that is less than B over 6. And the formula is this, no, 6M, P over BL times 1 plus and minus, ito na lang, P over BL plus 6M over LB squared, since moment naman talaga yung given. But yung moment na gamitin na is hindi ito. Hindi po ito. But ito ho. No? Ito. Okay? So, evaluating that, 190 kilopascal. Okay, 190 kilopascal. Okay, tingnan ko daw ba yung sinend ni Sir Tariga sa akin. May sinend yan si Sir Ronnie Tariga. Bending on both. Parang hindi nga. Parang wala, parang i-ask ko pa talaga si Sir Diego nito. Okay. Now, next example tayo. Dito naman. So, in this problem, given the following data, isolated footing, column loads 500 kilonewton, the moment is 300 kilonewton meter. If circular footing, sir, for circular footing, iba naman, no? Iba naman yung M, yung I, di ba? So, but minsan lang yun, no? Usually rectangular. Okay? So, footing dimension 2.4 by 2 meters. Na yung tanong dito, determine the maximum gross soil pressure. So, maximum soil gross soil pressure. So to solve for that maximum soil gross pressure, okay, better na i-calculate mo guys yung yung total, no? I-total mo lahat, okay? So gross na kasi tayo, di ba? Gross na, hindi na net. No, so ipang-add na natin sila, no? The P is not just the gross P is not just that, not just 500. Mag-add na tayo ng overburden pressure. No? So ito ho, yung B over 6, 2.4 over 6 is 0.4. No? Now, yung 500 over 300, 300 over 500 is 0.6. Now, if i-check natin. Okay? 300 over 500 is 0.6. Now, and this exceeds B over 6.4. No? So, in terms of the net, meron siyang uplift, no? Triangular lang yan. Triangular lang yung net soil pressure distribution mo. Okay? Triangular lang ho. No? Now, dapat yung pag-calculate natin, no, dapat total. So, total weight niya, weight of the footing, is it's, a product of gamma and the volume. So, 24 times 2.4 times 2 meters times 0.6. Okay? And that is equal to 69.12 kilonewton. Okay, weight of the footing yan. And the weight naman of the soil, okay, this soil dito is equal to gamma times 1. 17.2. Ay, yung total pala, no? Yung total. So, dapat parang volume din ito, no? That is 2.4 times 2 times 1. Okay? That is equal to 82.56. Okay? Total weight of the soil. So, yung total gross vertical force is equal to 500 plus 69.12 plus 82.56. Equal yan to 651.68. Now, the moment naman is pareho lang, no? 300. So, yung E natin, guys, sa gross is M over P. 300 over 651.68.46. So, still greater than B over 6. Meron pa ring uplift. No, meron pa ring uplift. Okay? So, triangular pa rin ito. No? So, with that, to calculate the Q na dito, we're to use the formula 2R over 3 times Bart XL. Okay, 2R times 3 times Bart XL, where R is equal to P total, which is the gross P, 651.68. And yung R. And yung Bart X naman, since nakalculate na natin yung E, not the overturning moment, huwag mong gamitin yun, yung in terms of, based on E lang, B over 2 minus E. So 2.4 minus 0.4604, that's 0.74. Okay? Or 0.7396 siguro, no? So that's it. Or about 0.74. So the Q max is 2 times 651.68, okay, 2R, over 3 times bar X, 0.74, times L, 2 meters, no? And evaluating that is equal to 293. Okay, 293 kilopascal. Okay? Ganun ho. Okay, Qmax kasi yung pinapahanap. Yung, if Q-nut yung pinapahanap, no, pwede, magbawas na lang tayo ng magbawas tayo ng gamma of the soil times the height, 24 times 0.6, yung sa concrete, at 17.2 times 1 naman sa soil. No, if Q max sa net. Okay? Unit max. Sir, kailan si Sir De La Cruz mag-lecture ulit? Next week. No? Available na si Sir De La Cruz next week. Kasi, he asked us to, rest muna. No? Yeah, next week. Okay. So, 262 kilopascal if QNet maximum yung i-solve. No? And again, triangular lang yung niya, distribution niya. No? Triangular lang ho. Okay, next example. Dami example ngayon No? Parang ano na lang to guys, parang dalawa, tatlo. Eto. Water stands, this is an HPGE past board exam, no? November 2023. Ito guys, water stands to a depth of 6 meters in a trapezoidal gravity dam with an upward stream pace 8 meters high. The dam has a top of 1 meter, okay, 1 meter, and a bottom of 4 meters, 4 meters, and the height of 8, no, and the depth of water is 6 meters, no, 6 meters to. Yan. No, the unit weight of concrete is 24. So, ipang-compute natin to. The factor of safety against overturning, the factor of safety against sliding using coefficient of friction 0.6, and the maximum foundation pressure. Okay? So, ma-relate lang natin to dito, guys, no, sa HPGE problem na ito. Okay? The same principle lang yung gagamitin. No? Now, yung may overturning dito is yung hydrostatic force. So, the hydrostatic force equal yan to gamma bar h times A or 1/2 gamma h squared times the length. But considering 1 meter length lang tayo, no? So, ganito, 9.81 times 6/2, kalahati ng depth, then times area, 6 times 1, 1 meter length, no? So, per meter width yung consider natin dito. So, 176.58 kilonewton per meter length of the dam. Okay, that's the hydrostatic force. Okay? Now, we are to find, again, the factor of safety against overturning moment, no? So, dapat ma-determine natin yung resisting moment and the overturning moment. Okay? Now, yung overturning moment is only caused by this, no? Yan lang yung makapag bigay ng moment about the toe, no? And i-resist yan by the weight, no? So, the weights are this, no? W1, ito na portion, no? 1 times 8 lang yan, no? 1 times 8 times gamma. So, gamma times 8 times 1, 192 kilonewton. Okay? And of course, that acts sa gitna, 0.5, di ba? Sa gitna. W2 naman, ito naman yung weight due to this triangular load, no? Ay, triangular portion of the footing. So, gamma times V2. V2 is equal, volume 2 is equal to 1/2 times 3 times 8. No? 1/2 times 3 times 8. Then times 1 meter width. 288 kilonewton naman yan. Okay? So, ang distances nila guys, dapat ano yun, no? Malaman mo, no? So, yung distance na ito is equal to 3.5, di ba? 3.5 yan. Klaro man, 0.5 kasi ito. And ito naman, 2/3 of 3. 2/3 of 3 is equal to 2, no? So, the writing moment is 192 times 3.5 then plus 288 times 2. Okay? That's 1,248 kilonewton. Okay, that's the writing moment. No? Then, again, the overturning moment, resisting moment. Pwede rin writing moment. The overturning moment is equal to, again, F times H lang yan. So, since, water na ito, no, triangular yung, distribution. So, height over 3. No, 1/3 of the height yung distance ng hydrostatic force. So, 6 over 3 is 2. So, 176.58 times 2 is equal to 353.16. Okay? 353.16. Now, ano yung factor of safety? The factor of safety against overturning is the ratio lang of the resisting moment over the overturning moment. Dapat kasi mas malaki yung resisting moment, no? So 1248 yung resisting moment divided by the overturning moment 353.16. Bali, actually guys, ito, no? Mas klaro ito as active and passive. Ito yung passive, no? Passive moment siya about the toe, no? Ito naman yung active moment, no? Yung overturning. Okay, it has an active moment about the toe, no? So yan yung dapat i-resist ng passive. No? So 1248 over 353.16, that is equal to 3.53. That's the factor of safety against overturning. Now, to find the factor of safety naman against sliding, i-calculate naman natin yung total weight niya kasi it should be ano yung total resisting force due to the friction, no? Dapat mas malaki yan compared to the active force, no? This passive must be greater than the active. The active is the F, the hydrostatic force. The passive is this Rx, no? Rx dyan is equal to mu times Ry. No? Mu times Ry. So, if we're to solve for Rx, 0.6 yan of the total weight. Sorry. Yung Rx, yan yung parang active na resisting force dyan. No, and that's equal to F, 176.58. Then Ry naman is equal to 480. Okay, that's the total weight, no? W1 plus W2. Okay ba? If we add natin to, that's equal to 480. No? So, yung resisting force, like the passive maximum resisting force is mu times Ry, no? Mu times Ry, and that's 0.6 times 480. Dapat mas malaki yan compared to Rx. So, the ratio is greater than 1.63. Okay ba? Sir, normal lang po ba na mag-gets yung topic during discussion pero pagdating na sa practice problem, kamote na? Ang di normal is kamote sa discussion tapos gets na sa practice. Ganoon talaga yan, no? So it takes more practice talaga, guys, no? Dapat ma-translate mo talaga into yung understanding mo ba sa lecture, ma-translate mo talaga into being able to solve the practice problems. Sir, tama ba sir na writing moment RM is moment due to vertical forces and OM naman is due to the horizontal forces? Um, no. Para sa akin, the overturning moment is, ano yan, not necessarily due to the horizontal, and the righting moment not necessarily due to the vertical, but this is like active and passive, no? Yung yung active force kasi dito is the force from the soil, from the water. Yung active. So, ano yung moment niya about the toe and yung overturning moment. Okay? Ganun siya, no? But the passive is the moment due to the weight about the toe. So, yan yung righting moment. Okay? Ito yung ulo ko, guys. Now, yung pangatlo naman, maximum foundation pressure. For the maximum foundation pressure, na yung gawin naman natin dito, guys, is gamitin natin, no, yung formula. Okay, since nakalculate na natin yung RM and OM, pwede i-determine na lang natin yung Bard X. The Bard X is equal to ano, RM minus OM over RY. Okay, so RM is 124. Then OM is 353. Then over RY, 480. Okay? So that's 1.864. Okay, Bard X is 1.864. Yung E, yung Bard X is gano'ng kalayo yan from the toe. Yung E is B over 2 minus Bard X. So that's 4 over 2 minus 1.864. That's 0.136. Then ngayon, i-determine mo na naman natin ulit, no, kung lagpas ba siya ng B over 6, no? 4 over 6 is what? 2/3. 2/3 is 0.67. Now, B over 6 is 0.67. So, less than lang siya. Ibig sabihin yan, the soil distribution dyan sa baba is trapezoidal lang. No? So, the formula, since the given dito, guys, is not the M, no? So, ito yung gamitin natin. Na RY over LB times 1 plus and minus 6E over B. Okay? And that is equal to 480 over 1 times 4 times 1 plus 6 times 0.136 over 4. And that is equal to what? 144.6, 0.48. Yan yung maximum foundation pressure. Yung minimum naman, if for us to find the minimum, i-minus lang natin to. 95.52. Okay? So, pwede rin na i-calculate mo yung moment dito, no? Mano-mano na pag-calculate, then gamitin mo yung 6M over BD squared or LB squared. Pwede rin ganun. So, ito yung soil distribution niya, guys, oh. Yan. Sir, may practice prob po kayo sa foundation. Yun nga, no, i-add ko lang kasi wala akong previous resources nito, no? And I was just asked to conduct the class. So, maghahanap pa ako. Baka si sir, merong na-distribute doon sa Manila. So, normal lang na after the discussion, skip ko yung practice problems, diretso ako si ERF. Second take ko now. Hindi yan normal. We designed the practice problems na ma-reinforce yung understanding ninyo sa topic na dinidiscuss, no? Ganun. They are usually based on the, past exams, no? So we suggest na mag-solve kayo sa practice problems, no? Para ma-reinforce ba? Para mas maintindihan ninyo, no? Yung CRF kasi, iba-iba yung topic, no? So iba-iba yung, hindi mo talaga ma-master yung mga na-discuss. Ba? Wait mo na guys, ha? Ano muna ako? Share mo na saglit. Okay. Uy, wait a minute. Andyan pa ba kayo? Parang na ano ba? Na close ko yung... Wait guys, ha? Nagsi-stream pa ba ito? Okay. Ilan ba yung viewers ngayon? 101. Okay, good. 101 viewers. Okay, this one. Dito naman tayo guys, no? So, given the following data of the Earth dam, so width at the base is 14 meters. No, the width at the top is 2 meters. The total height. Okay lang ba sir na no need na mag-CRF basta every practice problem sinasagutan? Hindi rin siya okay, no? Make it balance guys, no? Hindi pwede na parang na if you're focusing on this, you neglect the other one, no? Make it balance. Yung CRF, no? You would see in the CRF, you would know in the CRF the parang broadness of the topic, no, and different possible variation, no, what really came out sa exam, no, while sa sa practice problems tinitailor namin based on what we have been discussing, di ba, based on what we discussed. So hindi pwede na focus ka lang dito and ignore the CRF, hindi pwede na focus ka lang sa CRF and ignore the the sources. I know some of you are trying to find ways lang to to excuse yourself from doing some sacrifices, guys, no, and you want some validation. That's why you're asking these questions, no. Frankly, no, that's what you're doing, guys. Beneficial to take the It's for your good, not to take to practice the problems. Practice problems, and also to solve the past exams. Okay? Ganun. Make it balanced. Okay, pwede, pwede hindi mo muna ubusin. No? Like, in a day, no, practice problems. No, let's say, consume ka ng 5 hours solving that, another 5 hours, or 3 hours, CRF, ganun. No? Or 3 and 3. 3 hours solving sa exam, solving sa practice problems, then another 3 hours sa CRF. Okay? Ganun ho. Mag-extend po tayo, sir, most likely. Mag-extend tayo, no? Sige lang, parang last example na lang to, or merong hanggang saan ba ito? Sige lang, parang sumakaya natin. Okay? Parang last two examples na lang. So this one, given yung unit weight ng soil, 17.3, that's the weight of this earth dam, no? Earth dam. It's soil, not a concrete yan, no? No, this soil becomes like a dam, not to this water. Okay, it serves as a dam. Okay, the water, of course, has a unit weight of 9.81. Now, determine the factor of safety against overturning. So, against overturning, again, dito yan, no? Dapat the ratio of the righting moment not to the overturning moment is greater than 1. Dapat mas malaki yung righting moment than the overturning moment. No? So, mag-consider tayo ng 1 meter length, no, of the dam perpendicular to the figure. No? So, per 1 meter length lang. Ito yung mga i-determine natin or involve natin. The weight of the soil or the weight of the earth dam. Now, the weight of the water, okay, downward, the weight, the hydrostatic force, and ito yung toe, no? We are to take moment about that. Okay. So, ganito ho. Weight ng soil, that's equal to the unit weight of the soil times the volume of this dam. Na trapezoid lang yan, so average of the bases times the height. Okay, so 17.3 kilonewton per cubic meter yung unit weight ng soil. The area naman is 2 plus 14 over 2 times 12, that's the area, times the length na 1 meter. That's the volume. No? So, evaluating that, yung makuha natin is 1,660.8 kilonewton. Okay, that's the weight of the soil. Now, weight naman of the water, okay, yung vertical na force na yan, no? That's equal to gamma of the water times the volume of that liquid, no? So, eto is given, no, na to take note, guys, solve this, we need to do, dito? Magre-ratio and proportion tayo, no? So, the volume is equal to, to 1/2 of height times the base times the length, na 1 meter. Okay, so, we got this B sub 1, ito ho, that's equal to, the ratio, 6 over the height, which is 12, then times 9. Okay, or B sub 1 over 9 is equal to 6 over 12. So, B sub 1 is 4.5. Okay, 4.5 to. So, that is 1/2 times base times height. Height is 9. 1/2 times 4.5 times 9 times 1 meter, no? Length. And that is equal to 198.65 kilonewton. Okay, 198.65. Now, the hydrostatic force naman caused by the water is gamma, 1 half gamma h squared na lang yan, guys. 1 half gamma h squared. So 9.81, 1 half times 9.81 times 9 squared. Or, that's it. 9.81 times bar h, which is half of h, 9 of, height of the depth, 9 over 2, times 9 times 1. That is 397.31 kilonewton. Okay? Ngayon, if we are to solve for the factor of safety against sliding, against overturning, no, mag-take lot lang tayo moment, no? Pero pwede i-calculate muna natin yung Rx. Yung Rx, ma-solve by using summation of forces horizontal equal to 0. So, equal yan to this hydrostatic force na horizontal. Now, so 397.31 kilonewton. Now, sa vertical naman, the Ry, i-add lang natin, no, yung vertical Ws and WW. So, 1859.45 naman yan, na if i-add natin tong dalawa. Okay, 1859.45. Now, the righting moment is equal yan to the weight of the soil times this distance, which is equal to kalahati ng 14, which is 7, no, 14 over 2. Then, times W of the W times this distance, no? Which is equal to, 14 minus 1/3 of 4.5. Okay? So, the weight of the soil is 1,660.8. Moment arm is 7. Then plus weight of the water, ito, 198.65 times 14 minus 4.5 over 3. Okay? That is equal to 14,108.73. Yan yung righting moment. No? Parang yan yung resisting moment. No? Resisting siya. No? And yung overturning moment, ito yung makapag-uplift. Okay? Ito yung makapag-uplift. So this is just caused by the hydrostatic force, no? So that is equal to this FW, which is 397.31 times 3. That's equal to 1191.93 kilonewton meter. Okay? That is the overturning moment dito. No? Yan. So, ano yung factor of safety? Well, i-divide mo lang sila, no? Righting moment or resisting moment over the overturning moment. Okay, divide natin by RM over OM. Cancel ang M. So, 11.83. Ang malaki yan, usually, yung factor of safety against overturning. No? Yung next, the factor of safety against sliding, assuming that the coefficient of friction is 0.45. Okay, so against sliding, yung ano yan, mu Ry, which is the frictional resistance, na over Rx. Mu Ry over Rx. Okay, so factor of safety against sliding, mu Ry over Rx. So 0.45 times 1859.45, then over Rx 397.31, and that is equal to 2.1. Okay, that's the factor of safety against sliding. And for the third, compute the eccentricity of the resultant foundation pressure. Ito yung E. No, but since na-solve na natin yung RM and OM, pwede yung barred X muna yung isolve natin. No, barred X muna. No, and the barred X is equal yan to RM minus OM over Ry. No, so RM is 108.73 minus the OM 1191.93 over Ry 1859.45. So ito naman 6.947 meters. Okay, 6.947. And eccentricity is equal to b over 2 minus Bard X, or 7, yung b over 2 is 7 minus Bard X. So 0.053, yan yung eccentricity niya. No? Ganun ho. Ganun lang ho. Now guys, baka yung iba dito, since ano na lang, almost pareho lang yung principle, baka pwede na lang natin i-discuss mamayang gabi, no? Since ako lang naman yung yung magko-consultation, no? So, merong ibang prepared dito, no? I don't know if kaya ko bang ma-discuss to face to face, parang hindi rin, no? But I want actually later na makapag-discuss ako ng exam ninyo, no? So, similar na lang, no? Ito. Mga factor of safety. Pwede, isugutan natin mamaya, no? But I want you to try this one, no? I-solve nyo and sugutan natin mamayang gabi. Okay? Before tayo mag-discuss sa exam, no? And also kung ano ba yung ipakonsult ninyo. Okay? Sir, always po ba b over 2 minus x yung a? Yes. Always. Always yan. b over 2 minus Bard X. No? Bard X is the distance from the toe. Okay? So, guys, if you have questions, especially for this, this discussion natin this evening, consultation, I want you to use this Padlet lang, no? Dito lang consultation questions. Consultation questions. Okay? So, yan. Sige. So, i-upload ko yung PowerPoints na ito also last week. No, now, okay? Before ako mag-rest, no? Upload ko. Ito na ba, sir, ang dams na discussion sa HPGE? Most likely ganun, no? Kasi pareho lang yung principle. Okay? Pareho lang yung principle. I hope marami kayong natutunan sa akin, no? Medyo mabilis yung discussion sa last part. It's because pare-pareho na lang yung principle, no? Pare-pareho na lang, no? So, that's why parang binilisan ko na lang, no? But I hope nakuha nyo lang, nagets nyo lang yung principle talaga, no? Ganon. So, thank you guys. Later, no, at 6 p.m. mag-consultation tayo, no? So, if you have question, again, just upload it in this Padlet. Okay, so, goodbye everyone. Goodbye. See you later. Bye.